Hi, Dr. Kirschner. Good to see you. We are opening the room for folks to join us, just so you know, and they will be able to see and hear us.
Welcome, everyone. We'll get started in just a couple of moments. Thank you so much. We're happy you're here.
Hey, John.
Oh, hey, Tony, how are you? I didn't know I could hear you guys.
I'm glad I'm in the right place.
Yeah. I think all 215 people right now that have joined us can hear us too. So
It's okay. So be nice. Is that?
be nice. Ellie, when do we go ahead and get started?
We're just waiting for our captioner to test and be sure that all is set. And then once they let us know, we are good to go.
Oh, I see. Okay, that's good.
Just want to be sure that's set up appropriately.
That is great.
We should be all set. Thank you so much, everyone, for your patience.
Okay, so I guess we can go ahead and get started then as the captioning Oh yeah, I see somebody says it's ready. Okay, good. So Allie, do you mind just showing the first slide? Thank you. Well, it's just my pleasure to welcome everybody here to this ARO meeting for 2022. And I know we all wish it could be in person. And boy, we had planned to do it, but it just wasn't to be. And I mean, the good news is actually financially for ARO, we're in pretty good shape. We had kind of planned ahead and we could transition to an online meeting format quite, from my perspective, quite easily. I know from Parthenon's perspective, they had a lot of work to do and I really appreciate their efforts. Today, I'm really pleased to host this presidential symposium, Mentoring and Training Scientists, What Works? It's a topic of particular interest to me. You know, science, we all love it. We love developing hypotheses, testing them. It's kind of based on logic. It's a mystery, it's a puzzle we get to solve. Well, you know, mentoring is all about dealing with people, and a lot of that scientific rigor goes out the window when you have to you know, wrangle people to kind of help and work and learn. And that's why I'm just so thrilled to have these terrific speakers with us today. I could go to the next slide, please, Allie. So we have a great lineup. We're going to hear 4 speakers first in the morning, and then we'll have a very short break or catch-up time if we run late. And then 3 more speakers. And the last 2 prefer to kind of lead it as a panel. And so we'll also have a bunch of panel speakers with them. Okay, next slide. So I just want to introduce Barbara Oakley. She's a distinguished professor of engineering at Oakland University in Rochester, Michigan. She's also a New York Times bestselling author. She's published in PNAS, the Wall Street Journal, and the New York Times. She co-teaches Coursera's Learning How to Learn, one of the world's most popular massive open online courses with over 4 million registered students. Dr. Oakley has adventured widely throughout her lifetime. She rose from the ranks of private to captain in the US Army, worked as a communications expert at the South Pole Station in Antarctica, and has served as a Russian translator on board Soviet trawlers in the Bering Sea. Barbara, thank you for coming and giving us this presentation on learning how to learn.
It's my pleasure. Okay, so I will go ahead and begin. I'm going to share screen. And here we go. I'm going to open with my favorite athlete of all time. That's Julius Yiko. And Julius he's from Kenya. If you know anything about Kenya, you know they're very famous for their long distance runners. But if you look at Julius's arms, it is clear he is not a long distance runner. And indeed, he always wanted to learn to throw the javelin. But there were no javelin throwing coaches in all of Kenya. And he didn't have the money to go overseas and, you know, learn from the great javelin throwing coaches. So instead, he went online to YouTube and started watching really good YouTube videos on how to throw the javelin. And simply by watching and going out and practicing, he became, well, 99% only by doing that, he became the world champion in throwing the javelin. So despite the drawbacks of us being here in the virtual world, I think that's a really encouraging message for us that even online, one can learn really extraordinarily well and learn new things. So what I want to just briefly introduce you to here today is the idea of what is really going on in our brains when we're learning. So you're all scientists, you're all well-trained and know biology, but I'm just going to do a quick review because sometimes we tend to think of learning as this thing that somehow there's some biological goings on, but we don't really think about what it actually is. And once we think and know what actually is going on, at least to some extent, it can help improve our abilities to learn. and our abilities to teach and mentor others. So learning, what is it? It involves the, obviously a fundamental building block of the brain is the neuron. There's 86 billion of them. And I know you're all familiar with sort of the major attributes of the neuron. And what neurons do is, in essence, as you know, they communicate, they send signals from oops, let's try that again. They send signals from, let's see, why is this a little bit funky here? There we go. They send electrical signals between one another and, of course, jumping the gap with neurotransmitters. And it's these connected neurons that actually form engrams or are memories. And when you learn anything, you are creating sets of links in long-term memory. So this means that you can't just always look it up, because you have to have some fundamental ideas built in as a structure in memory. For example, you would not be able to speak French if you just were always using Google Translate to look it up. And similarly, when you're learning fundamentals of calculus or statistical methods, or how to use a skateboard, whatever you're learning, you must have fundamental skills or concepts embedded in sets of links in long-term memory, or you really don't understand it or don't know it and can't do it yourself. So those connections actually can strengthen with practice. So it's, that's part of why we practice. We create these sets of links in long-term memory, and we can easily pull those sets of links to mind into working memory, and then we can work with these, with whatever we've learned, because we've got them in mind. So this brings me to a fundamental idea in learning that's very, very important. And that just relates to the idea of, metaphor, the value of metaphor. When you're creating sets of links, as I'm showing right here, so here's sets of links. As you practice, you create this nice long structure or interconnected structure. You can easily pull it to mind. But then once you know something, you can more easily use that knowledge to create or to understand new sets or new information. So metaphor, when you're trying to teach an idea, one of the best tools you can use is to use a metaphor for your learning or for your teaching. So for example, let's say you're trying to teach the idea of electrical current flow. Well, actually, it took people a long time to figure out how electrons are flowing, and they even got it the wrong way. Of course, it's not positive particles flowing along, it's negative particles flowing the other way. But in any case, if you use the simple idea of the flow of water to convey as a kind of a metaphor to help bridge people into this new idea of what electrical current flow is doing, they can much more quickly grasp the idea. Now, different metaphors are going to give you a slightly different conceptual understanding. For example, if you use water flow as opposed to the flow of crowds, you're going to understand electrical current a little differently, but that's all good. Does the metaphor break down sooner or later? Of course, every metaphor breaks down. But when a metaphor breaks down, as when you get to quantum levels in electrical current flow, you just throw it away and you get a new one. Because what you're really trying to convey with metaphors is the essence of the idea. And if the peripheral things don't quite fit, as long as you've got that essence, that's a big step forward for students. But this brings me to something that people often don't really quite understand. For years, people have used a variety of methods to try to learn information. And I'm going to give you 4 different commonly used methods for learning. And what I want you to do is sort of get into your mind which one of those 4 methods is the one that you personally use, or if it's methods, which one you use most often, and which one do you think is the best? So here's the 4 methods. There's rereading, or highlighting, or underlining. I mean, both of those are ways of repeating and emphasizing materials. And then there's retrieving something to mind, like recalling, using a flashcard to look at a word in a foreign language or an anatomical term, flip the card over, and see if you understand, or you can retrieve before you flip it over what the answer to that actual problem is. And then there's also creating concept maps. And you can see here a concept map just kind of relates all these key ideas. So you're drawing and putting out on paper what the key ideas are that you're learning. So hopefully you have in mind which one you think is best. And I will tell you that most people pick concept mapping. Why? Because we've been told that concept mapping is really the best. And also I kind of did a little bit of a cheat here. I put a picture with concept mapping. But when a scientist actually studied these 4 techniques to see not only which one was best for remembering, but which technique was best for understanding, he found retrieval practice was by far the best. And this was published in the journal Science in 2012. And since then, there's buckets full of research that shows that retrieval practice is really the best way to go by far, far better than rereading, highlighting, concept mapping, or any other approach that's been found so far. So retrieval practice, why would it be so powerful? When you're first learning something, as when I'm explaining something right now to you, you get these faint sets of links. So you are forming links with my explanation, but it is when you go off and you retrieve that initial learning out of your brain, you retrieve it. Each time you do that, you strengthen those sets of links. And that is the magic that really helps with learning. So after you're done with the sessions today, or even after each session, try to pause and retrieve what you got as the key ideas of those sessions. And that will help those ideas to embed much more deeply so that you'll be able to use them later on. Now, what happens when you don't retrieve? Well, we've got our little dendritic spines, and those are connecting to things. But if we're not using those spines, what happens is our little synaptic janitors, so to speak, can make those spines disappear. They sweep them away. So it really is a case of use it or lose it. It's part of why we sleep at night. It is to erase dendritic spines that are not important. So this is why retrieval practice and also spaced repetition is so important. I'll just give you a quick, this is a light microscopy image of a living neuron before learning and before sleep. And this is the same exact living neuron after learning and after sleep. So if you look here, you can see a little dendritic spine that is emerged that wasn't there before. And this is part of what happened during the sleep process. These dendritic spines emerge and make connections. Other spines, of course, just kind of die away. They go back into the neuron. So it's a fascinating process. And in any case, what this really means is it's important to space out your learning, to do some repetition or some retrieval practice each day with what you're learning, rather than sitting there and just cramming everything into a one big long session in one day. So if you do that, your little synaptic janitor can more easily sweep those poorly connected dendritic spines and connections away. What's happening, let's say you have 5 hours to learn. If you do 5 hours of cramming, you have no sleep to allow your brain to reinforce those dendritic spines. If you space those 5 hours out, so it's like an hour a day for 5 days, now it's not only that you're learning when you're learning, but you're also learning because at night, your brain is sending electrical signals hundreds of times over the pathways that where you've learned important information for that day. This can be why it's valuable before you go to sleep. You don't want to be like cramming before you go to sleep, but if you've learned during the day, encourage your mentees to sit right before they go to sleep and take 5 minutes and review the key things they really wanted to learn, so that it signals the brain, that's the stuff I want you to be running through and practicing those particular pathways during sleep, and it will help improve learning during sleep. So if you want a metaphor, I have millions of them, well, at least thousands. So it's a little bit like building a brick wall. You lay a layer of bricks, some mortar, but before you go too high, you let that mortar dry. If you don't do that, if you don't take your time in learning, you have something like this, which is really quite a poor foundation for learning. So I just want to communicate one final important thought, I think, related to how we learn. And this goes back to Julius Yiko and how he was learning. We often don't think about it this way, but research in learning, there was it was probably the largest ever study for 9 years involving hundreds of thousands of students and thousands of schools and teachers. And what this study showed was that there was a particular form of learning that was really the most teaching that was most beneficial for people. So what was that? We know that lecture, like 2 hours of lecturing all in a row, it's maybe really efficient for the teacher and efficient for the students in that we can get them together for that 2 hours. But it's actually not the most efficient pathway for learning. And so we've kind of figured that out. So in the last 40 years or so, there's been a big movement towards active learning as being the best for us to be able to get that information inside long-term memory. And so it's become something that is so popular that people almost sometimes don't look at the fact that, active learning all the time doesn't work either. I mean, you don't just like plop somebody down and say, okay, now learn actively with it. I mean, some lecture actually helps people with learning. Like if I just plopped you down right now and say, okay, you guys figure out what's going on with learning, it would take you years to come up with the same simple ideas that I'm conveying to you now based on long study of the wonderful insights from cognitive psychologists and neuroscientists that I'm conveying here right now. So what is really going on is we're beginning to discover that actually a mixture of lecture and active learning really seems to be the best. The teacher conveys the information and then the student actively works with it. Now, how long should the lecture be versus the active learning session? we don't know yet. It depends a lot on what the subject matter is, what the student's own internal makeup is, what their background training is. We just know that it's some kind of mixture of lecture and active learning seems to be the best. And this indeed was borne out with this enormous study of, it was 10 different approaches to learning that it included approaches like improving self-esteem, sort of growth mindset, sorts of ideas, and all sorts of different approaches. But what they found was, of these 10 different approaches to teaching and learning, direct instruction stood out so far ahead of all of the other approaches to teaching that, surprisingly, the study was not published. And part of it was, I mean, if you're in one of the 9 other groups that was found to be not nearly as good as direct instruction, this mixture of lecture and active learning, it can be a little demoralizing to learn that your approach is way behind another approach. And think about it, 9 groups opposed to 1. So despite the enormous cost of this whole study and the length of time, it was not really popularly conveyed to the public. So, but what is really going on with active learning or with direct instruction? We have, here's our Julius. He's learning how to throw the javelin. And so he would watch the videos, and then he would go out and he would practice by throwing the javelin. So he'd sort of learn through lecture, then go and practice. So in some sense, what he was doing was lecture versus active practice. Lecture, active practice. And by this combination, he learned to be very successful in throwing the javelin. You might think, oh, well, that's just for physical learning skills. But no, it's actually, this type of learning works beautifully for learning math, for learning to read, for learning all sorts of things. And how does this relate to what's really going on in the brain? Turns out that the brain has 2 major superhighways of learning. So one, I talked about the sets of links that are created, but they're created through these 2 different pathways. The first takes information from working memory in the prefrontal cortex and conveys it through what's called the declarative system, which uses the hippocampus, into long-term memory. The other sets of links go through what's called the procedural system of the basal ganglia and create sets of links. As it turns out, both sets of links are really important and used together oftentimes in learning. So you can be really fast, but also flexible in your learning of math and your handling of mathematics or language or whatever you're learning when you have a combination of these 2 different approaches. Now, the bottom line is that there are, and I could go in depth into it, but just to briefly convey here, you might think of it as there being different kinds of learners. There are race car learners who can learn really quickly, and there are more like hiker learners who learn more slowly. But think about the difference between these 2 different kinds of learners. The race car is able to get to the finish line really fast, but everything goes by in a blur. For a hiker, they can get to the finish line equally, but much more slowly. But during that time, they can they can reach out and touch the leaves on the trees. They can smell the pine in the air, see the birds. It's a completely different experiences. And in some ways, it's far richer and deeper. So, what is really happening with that? Well, we need both types of learners. And here's part of why. A slow learner, and I include myself among them, and in fact, Nobel Prize winners, including Santiago Ramon y Cajal, the father of modern neuroscience, were slow learners. And what's really going on is they have those dendritic spines, and they learn during the day, they've got these spines, but then at night, a lot of those spines fall away, they forget. Now, a fast learner, on the other hand, their dendritic spines, they may lose some at night, but they have a differing bath of neurochemicals that means that they stay more solidly in place. But here's the deal. The next day, the slow learner is like, I forgot it. Now I got to restudy it. I'm nowhere near as fast as those fast guys. And so they have to relearn, but look, slightly different configuration. In fact, there's plenty of evidence that slower learners can be more flexible learners. So, as I mentioned, my hero in science is Santiago Ramón y Cajal, the father of modern neuroscience. Terrible student, flunked out of elementary school, really struggled to learn the mathematics and so forth. But he was asked, he was enormously successful, and he was able to look at things in a different way than many of those who he worked with. He was asked, how were you so successful? And he said, well, for one thing, I was persistent. So even though he had to work harder to kind of bring those ideas back to mind and in order to reshape and actually learn something, he was persistent about it. But the second thing he said was, I'm flexible. And when I have a hypothesis and I'm wrong, I can change my mind. He said, I'm no genius, and he was not. But he said, I've worked with many geniuses. And the challenge with geniuses is they can tend to jump to conclusions, and then when they're wrong, they can't change their mind. Instead, they will just use their intelligence to somehow justify why they must have been right after all. So if you or your students are no geniuses, rejoice, because they can still do things that even geniuses cannot. So with that, John, I back over to you, and thank you so much for allowing me to share.
Oh, Barbara, thank you so much. Wow, you've given me hope. We have time for maybe one or two questions. I see one right here. I'm just going to read it aloud. Some scientific experiments show that every time you recall an episodic memory, you are rewriting the memory, and it is more susceptible for editing the memory or even possibly forgetting it. Is this process for memory recall, which could be a negative outcome of retrieval, different from what you discussed as the pathway and effects and evidence for learning, recall, and retrieving it constantly?
That's a very good question, and a very sophisticated one. I think the long and the short of it is that every time you retrieve a memory, actually, even when you are not retrieving memories, there is good evidence that that different neurons, and we don't understand how this is going on at all, but there's neural drift. In other words, different neurons are remembering that same thing. So even when you're not retrieving, things are changing. Absolutely. When you rewrite or when you retrieve, it can be rewritten. But if you're comparing sort of with reality, you've got sort of a check to balance things against. Now, a challenge for really, really intelligent people is that they can remember really pretty well. In fact, super well. In fact, they can remember so much that it can be difficult for them to see the forest for the trees. In other words, they've got a good knowledge, even if it's, it's a little bit like the ocean, it's flexing a little bit here and there, but they have a very, very good memory, and that can make it harder to abstract big ideas. Now, there are some people who are able to do both. They're able to see the smaller and also the larger. But many people who really can remember very well, and think of, so for example, some famous judges on the Supreme Court, they could tell you which page of which book and what section on that page was a key finding, a key result that they wanted to refer to, and they could remember it all. So yes, memories can change, but some people have exceptionally good memories, and it all depends on that differing bath of neurochemicals. So I certainly wouldn't say don't retrieve because you're going to shift your memory, because I certainly could have never, honest facts here. I was terrible at math and science when I was growing up. I enlisted in the army out of high school, learned Russian, realized by learning Russian that I could actually learn many, many different things. So I went back to the university and eventually got my doctorate, and I am now a distinguished professor of engineering. But if I hadn't learned to retrieve when I was learning Russian, I would never have been able to speak Russian and never gone on to do the subsequent learning.
Wow. Barbara, thank you again so much for speaking to us today. I'm afraid we just don't have time to go through all the questions that are coming in, but boy, that was a wonderful way to kick off our meeting. Thank you.
Thank you.
Allie, could you bring up you bring it up right now. Okay, great. It's my pleasure to introduce Dan Levitin. He's the James McGill Professor Emeritus of Psychology and Neuroscience at McGill University. He's the founding Dean of Arts and Humanities at the Minerva University in San Francisco, and an adjunct professor of neuroscience at the UCLA Geffen Medical School. His research addresses fundamental questions in musical memory, musical structure, and the neuroanatomy and neurochemistry of musical experience. He's the author of 5 consecutive best-selling books, including This Is Your Brain on Music. Furthermore, he's sung professionally with artists, including Neil Young, Roseanne Cash, and David Byrne. I met David because his wife is a collaborator of mine for many years and a dear friend, Heather Bortfeld. And then I met Dan through her, and he's also become a dear friend. Dan, we're really looking to your talk today about how to mentor students. Thanks for speaking with us today.
Thank you, John. I'm just delighted to be here. And you can just all think of me as Mr. Bortfeld, because my wife is really the real scientist in the family. But yes, I'm sorry not to be there in person. And what a tough act to follow from Barbara Oakley. I'd like us all to just close our eyes a minute and think about what she said, and then I'd like each of you to say out loud, you can turn your mics on or not, it doesn't matter, but say out loud the one thing that you found most important about her talk. On 3. 1, 2, 3.
Oh.
So practice, retrieval, active learning, there was so much spaced practice, there was so much dendritic spines, there was so much packed in there. And it reminds me that ideally we'd be doing this in person, and you would be doing the talking most of the time, which is the active learning part. But maybe we can save some time for that at the end. John asked me to talk about mentoring graduate students. What I have to say applies primarily, I would say, to programs that prepare them to be scientific and medical researchers. As most of you know, training clinicians and physicians is usually different, and it leans on some overlapping and some distinct forms of mentorship. But training scientific researchers has some unique features that I'd like to drill down on. And of course, training clinician researchers is the best of both. And I want to also begin by saying I don't know a whole lot about this topic, but as I get older, I realize I don't know much about anything. The more I learn, the more I'm aware of what I haven't yet learned. And that, I think, is a segue into where I want to go with this. Science training requires that our students make a fundamental paradigm shift in the way they view themselves in the world and the way they view their education. Think about it, right? If you're training students at the graduate level, they must have been great students up to that point, right? I mean, you're getting your pick of the very, very best. So they've been at the top of all their classes all the way, for the most part. I mean, there are exceptions like Ramoni Cajal, but for, in the main, they've been at the top of their class in elementary school, which got them into AP classes in high school. They were at the top of those, which got them into an undergraduate program. And then they apply to graduate school with all this bravado and with all this sense that, yeah, I'm number one. And then when they get there, our job is to help them transition from being full of themselves to being full of wonder, from thinking that they know everything to realizing there's still things for them to learn. Because up until that point, they walk through the portals of your laboratory or your program, day one, first year graduate school. They just think they are all that. And they are, but if they think they know everything, they're not going to be able to learn anything. And that's the pivot. They have to, at the same time, become consumers of knowledge, where for the most part, knowledge has been handed to them in the form of textbooks. Learn this, spit it back, and then you're going to get an A. If they're going to be researchers, they're going to be creating the knowledge, not just consuming it. And the creating of it means that they have to stop assuming that published findings are unequivocally true and start questioning the truth of what they read and the methods used to find them. So this is why we have journal clubs and brown bags and reading groups and grand rounds. It's to poke down into the literature and say, well, gee, I don't know how that got published. And in my lab, as well as in the labs I was trained in, I would say 80% of the time, we would read a paper, even in a top journal, and say, how in the world did that ever pass peer review? This is full of holes. And often out of that came an idea for a new experiment where we would plug the holes, where we would add a control group that was missing. That's becoming a creator of knowledge, an intelligent skeptic. And it's a difficult transition to make. We've all had the experience, I think, where a graduate student will say, well, what do you want me to read? And, well, there are two approaches to that. One is you give them a list of things that you've read or that you've wanted to read, even better. They read them for you. Or you say to them, you figure it out. This is what you need to know. You need to figure out how to teach yourself, because when you leave our PhD program or our PhD MD program, that doesn't mean that the learning stops. That doesn't mean you're done. That's when it actually starts. When you have the degree in hand and you're building your own laboratory or becoming a senior person in someone else's, you need to be a lifelong learner. That's what I mean by a consumer of knowledge to a creator of knowledge. Creating the knowledge by figuring out your own problems. And of course, this requires that our students change a fundamental aspect of their self-image. As I said, they have to go from thinking they know everything, that's how they got into grad school in the first place, to realizing that they, and more importantly, we as scientists, actually know very little. My own education was just terrific, and it was a happy accident. I was in a PhD program in a faculty of science. I then had 2 years of postdoctoral training at the Stanford Medical School. I'm currently cross-appointed in a faculty of science and a faculty of medicine at McGill, and as John mentioned, the faculty of medicine at UCLA. And although many of my students become doctors and devote their time to clinical practice, most of them become researchers or researchers clinicians, and this poses the special challenges and opportunities of what do I know and what do I not know? When I was in my second year of an assistant professor at McGill, I was on doctoral committee as what at McGill we call an internal external. That is, I was internal to the university, but external to the department. So we had a biology PhD coming up to defend the oral defense of his thesis. And his thesis studied a particular aspect of the visual system of the squid. 30 years ago, this would have seemed very narrow. I'd go so far, I'm a fan of the history of science, as I know many of you are. You go back 100 years, 1922. If you got a PhD in biology, you probably knew everything there was to know about the squid. There just wasn't that much known. You probably also knew everything there, I mean, that goes without saying, you probably knew everything there was to know about the visual system of the squid, because as a PhD in biology, you knew everything that anybody knew about the squid, and you knew everything that anybody knew about the frog, and so on. You go back 200 years, PhD in biology, you probably knew as much as anybody else with a PhD in biology. Now, this poor student who's defending his thesis, the external, that is the Caltech biologist who was grilling him and had read his thesis, noted that there were 1,000 papers published the year that this student submitted his thesis. 1,000 papers in the previous 12 months just on the visual system of the squid. How could this poor student hope to be expert on that? He couldn't. And fortunately, his advisors counseled him when asked questions like, what does the paper by Ogilvy, Chatterjee, and Kegler say about the visual system of the squid? The student had to say, I'm sorry, I have not read that. I will put it on my reading list. But I did read these 300 other papers that are directly relevant to what I'm talking about. It's okay to say I don't know. In fact, I came to learn a kind of simple, you could call it a Turing test type of a thing, a quick probe. By Turing test, I mean a quick probe decision tree point of how do I know if my graduate student is ready to defend their thesis? It could be very subjective, right? I mean, well, okay, when they get 3 experiments done, when they've got 3 publishable manuscripts, whether or not they've been published, when their committee says they're ready, when you feel they're ready. The rubric I came up with that works pretty well is invariably, at some point, it's usually 4 to 6 years in their PhD program, I get a sheepish little knock on the door. And the student says, I don't know why I'm even here. I've been conducting experiments. I've probably read hundreds of articles. I go to all the brown bags, all the colloquia, and I just realized I don't know anything about the field. And I stand up and spread my arms and I rejoice and I say, congratulations, now you're ready to defend. Because it is that attitude of humility that will get them far. It's that attitude. If we can teach them one thing, I would say teach them humility. Teach them that they don't know everything, and that is the opening that they can learn, that they can actually embrace the principles that Barbara Oakley so eloquently laid out for us. Why would you want to practice if you already think you know everything? Why would you want to exercise your retrieval skills? Why would you want to sleep on it and space out the practice if you didn't think that you needed to learn more? Now, in parallel to all of this, there are definitive neuroplastic changes in the brain that Barbara touched on that can support or hinder these attitudinal shifts. And these are a function of age and individual differences. We were saying 10 years ago that the frontal lobes, particularly the prefrontal cortex, doesn't fully develop until age 20. And this has spilled over into the courtroom where a number of defense attorneys have said, well, you can't hold a 19-year-old responsible for a heinous crime because They lack impulse control, and the GABA receptor network isn't fully developed. Now, some of the newest papers are saying it's not 19, it's 25. You don't have impulse control till you're 25, and some people never develop it. You've got frontal lobe syndrome and chronic frontal lobe syndrome. And I'm not weighing in on the legal questions, although my colleague Robert Sapolsky has been delving into that, and I'd encourage you to look at some of his recent thinking if that's an area of interest to you. But what we're learning again, in the spirit of humility, and I don't know it everything, neuroscientists are increasingly looking to personality and individual differences psychology, and vice versa. And now within the large umbrella of social and personality psychology is social and personality neuroscience. And what we learned here is that humility and honesty are personality traits. There's recent evidence, just in the last 12 months, that humility and honesty, although in the traditional Big Five model of personality, are considered loading on agreeableness and conscientiousness, they're probably a sixth orthogonal factor. Humility, a separate personality factor. And the other thing we've learned in the last 5 years or so is that personality traits are not set in stone. We kind of knew this 20 years ago, but the evidence is mounting. You can change your personality. How do you do that? Well, with encouragement from mentors, with modeling behavior of mentors, with modeling behavior of colleagues and friends. Other ways, some people change their personality traits through psychotherapy, or through meditation, or through medication. There are people who, for medical reasons, are suffering from dopaminergic depletion. Goes under various medical treatment and medical diagnostic codes. But if you're deficient in dopamine, you're going to be deficient in the desire to explore, to learn new things. You're going to be deficient in curiosity. And curiosity and humility are partners. They really serve to feed one another in a circle. And so I say we can encourage personality change, and the wonderful nexus of neuroscience and mentorship and personality is that if we model and teach humility, if we teach intellectual honesty, which really comes down to humility as well, if we teach curiosity, which is perhaps the most important factor in longevity and the most important quality that a scientist can have alongside honesty. I mean, don't get me started on the replication crisis owing to a bunch of falsified data. Another topic, another time. But yeah, honesty and curiosity, which can support humility. We model it, we encourage it, we train it, and we try to develop lifelong learners who realize that knowledge and the nature of knowledge changes. There's always something you can learn from other people. I think that is the key to mentoring graduate students. And we see it not just in science, but we see it in arts. Any of you who have heard of Benjamin Zander, the wonderful conductor of the Boston Philharmonic, not the Boston Symphony Orchestra, which is more well known and which spawned the Boston Pops, but the Boston Philharmonic, which is a student orchestra in Boston and performs concerts at a very high level, bringing in world-class soloists. Benjamin teaches the students that if they make a mistake, rather than cowering in their seats and being afraid that the conductor is going to throw a baton at them, they are to stand up, spread out their arms, and yell, "Aha!" The aha moment, and then everybody in the orchestra applauds. The aha moment is, wow, I just encountered an area of my own lack of knowledge. If I made a mistake, it means I discovered something I don't know. This is a moment to rejoice, because now I can set about the business of learning this thing that I thought I knew, but that I didn't know. And what is this other than a kind of model of what we do in our journal clubs and our lab meetings when somebody says, there's a flaw in this paper that I wrote. I just discovered it. Or I just found this old paper from 100 years ago that discovered something I thought I had discovered. That's the aha teachable moment. I think what I've learned from mentoring, and it's just me copying my own wonderful mentors, who I got, I mean, it was pure luck of the draw, but I had wonderful mentors in Mike Posner, who was my doctoral supervisor, Doug Hintzman and Helen Neville on my graduate committee, Terry Takahashi, a biologist, postdoctoral positions with Steve Palmer at Berkeley, Alan Reese at Stanford Medical School, Gary Glover in neuroimaging there, just to a person. Each of them taught me to embrace my mistakes and to encourage other people to not be ashamed of theirs, because really that's what's necessary for us to move forward as scientists. And I'd like to stop there and spend the next 5 minutes in conversation and Q&A and hear what your thoughts are.
Wow, Dan, thank you so much. So much of what you said resonates with me personally. There is a question here, and please feel free to type in any, the audience can type in any other questions. I'm going to read the question. You mentioned that it's our job to teach our graduate students to trade their overconfidence for a sense of wonder, and I agree. It seems to me the #1 indicator of whether a student has what it takes to be successful is that passion for lifelong learning and that limitless, curious wonder. But how do you teach or instill that passion, for learning?
That's a tough question. Donald Hebb, who was at McGill, our department chair at McGill, and was my predecessor in teaching the intro course there, he used to say about graduate education, I don't claim credit for the good ones, and I don't take the blame for the bad ones. To some extent, you can't train everybody to be everything, of course, but you can model curiosity. I remember, this is a little bit off topic, but I remember taking piano lessons because I was a dual music major, and I had a world-class concert pianist, Earl Blue, who was my piano teacher in college, and we'd spend most of our lessons with him telling me about stuff he had read in the newspapers, not about how to play the piano. He was curious about the world, and we would talk about that, and he would find things that were either stories of great beauty or stories of great pain and tragedy. And then he channeled those into his performance of the piece I was learning. His curiosity spilled over. And so I happen to consider myself something of a generalist. And so I try to get my students interested in things that are outside and to find, as Barb was saying, find analogies from other sciences or from philosophy or from art. But even if one is a specialist and a hyper-specialist, I think you model curiosity, and it's latent in all of us. Every parent knows that 4-year-olds are continually asking, why? And we have it drummed out of us. It's there. It just needs to be reignited if you can. And then, of course, there's some people where it doesn't take for whatever reason, but all you can do is try.
Yeah, I agree, Dan. One more question. How should graduate students navigate tenured professors that think they know everything and may cause students to experience imposter syndrome?
Well, this is tough. I was on our graduate education committee at McGill and on the graduate student grievance committee, which are separate jobs. I never hold both at the same time. And so I saw a lot. I would say to a graduate student, what I always said to my graduate students, find some ally in the department who is not me. Find someone who you resonate with. They don't even have to be in your field, but somebody who knows how the system works and understands the personalities and can give you a different perspective. And, you know, although we typically have a mentorship model in which you work in a single lab, or possibly you rotate through labs, but at the moment you have a primary mentor, I think it's in everybody's best interests if the student assemble a committee. Some programs require it, some don't, but it can be an ad hoc committee. 2 or 3 professors you meet with a couple of times a year, just chew the fat, maybe go out for pizza with them, and when you run into trouble, you know that they've got your back.
Yeah, thanks. Okay, and I'm going to read one last question and then we'll move to the next speaker. Okay, oh, this is interesting. It's got remnants of Donald Rumsfeld in here. As a graduate student, as a graduate student, one of the difficulties we face in mentorship relationships is being honest about what we do not know, especially when it feels like it's something that you should know. How do you think graduate students should approach facing this aha moment with their mentors when they don't even know that they don't even know what they don't know? Interesting.
That is a rummy moment. Well, yeah, it's, you know, there are things that we know. There are 4, you know, it's a 4-cell problem. There are things that we know, and what I would say is be a little bit flexible about that. They're not things that we know absolutely in science. We never prove anything. They're things that we know provisionally because the weight of evidence is there. There's things that we know that we don't know, and there are things that we don't know we know, but we know them implicitly. This was Chomsky's whole thing. We have implicit knowledge of grammar. And then there's the Rumsfeld corner down at the bottom. Things that we don't know. And those are the things that get us into trouble. That's what causes somebody to attach a jet engine to their Chevy Impala so that it will lift off the ground, and didn't realize until it was too late that the brakes no longer work once it's airborne because the tires aren't touching the ground, and so they crash. I mean, this is the recipe for disaster. And nobody that I know of, I've read a lot of philosophy on this, and Lee McIntyre is very good on it, but nobody has a magic bullet or a magic formula for how to deal with the unknown unknowns, other than consulting widely and reading widely and being alert to it. There may be things I don't know, and check your confidence. Overconfidence is the cause of most human-made disasters, whether it was the Challenger explosion or the Exxon Valdez, or terrible outcomes in surgeries, which, you know, many of which are accidents and unavoidable, but many of which were overconfidence. And so, again, I think we don't exist in a vacuum as scientists. We exist in a network of collaborators and colleagues, and hopefully they will tell us when they think we're being overconfident. And we have to have the humility to embrace that and accept it.
That's a great way to end, Dan. Thank you. Yeah, humility is so important and so hard.
And in short supply these days.
Yes, it is. Thanks again, Dan. We really appreciate your time this morning.
You.
Okay, let's go back to the, oh, perfect. So it's my pleasure to introduce Joe Kirschner. He's the Julia Uline Dean of the School of Medicine and Executive Vice President of the Medical College of Wisconsin. He's held this role since 2011. Joe assumed the additional role of Provost of the Health Sciences University in 2017. He's also professor in the departments of otolaryngology and communication sciences and microbiology and immunology. He maintains an active research laboratory and he studies otitis media. And he's been continuously funded by NIH since 2001 and a long member of ARO. As might be expected from somebody in his position, Joe's been deeply involved in medical education and mentorship throughout his career. I asked Joe to come talk about it from a financial point of view, as as I've come to realize how important the funding issues are in trying to maintain top educational and research programs. And so I'm looking forward to hearing your thoughts on this, Joe.
Great, thanks, John. And if we could bring up the slides, I appreciate the opportunity to be here this morning. And like the other speakers, do wish we were in person, but someday soon. It's tough to follow those first two speakers. Actually, it'd be a lot of fun just to donate my time back to the presidential symposium and just go through some of the questions and delve deeper into those conversations. But John might be unhappy with me if I did that, and there's probably a rationale for me to do this talk. So John, here come the slides. Yep, perfect. So we can go off the title slide and move to the next one. So John asked me to come talk sort of about funds flow as it relates to this idea around our academic missions. Most of us, or many of us, are part of a medical school or certainly a health science university that has a need to support the things we're talking about. So while the fundamental aspects of how we educate and how we mentor and how we provide resources for our research missions are critical, there are individuals, and I see that Lloyd Miner is coming up to talk as well, and Lloyd does much of this work in a similar fashion. But somebody is making the decisions about what is possible from a funding perspective. And so we can, and I love those first two talks, and we can have the greatest ways in which we learn or teach or provide educational resources. We can be fantastic mentors. We can have wonderful ideas as scientists and be humble in how we approach our learning and discovery. But at the end of the day, if there is no margin, there's no mission. And so in my roles here at the Medical College of Wisconsin, in the dean's role and the provost role, I spend a lot of my time. John mentioned I still have a funded lab, which I do. I'd rather spend more time in the lab, but I spend a lot of my time trying to help make these decisions about how we have the funds to support this. And so, you've heard this quote, which is, if you've seen one academic medical center, you've seen one academic medical center. There's a lot of truth to that, but there is overlap in many of these concepts, and I'll try and share some of those ideas. I've had the privilege in working nationally on the board for the Association of American Medical Colleges and chaired that board until just recently. So during that tenure, I had really the privilege to intersect with most deans in the country, many of them on a deep level discussing this issue, and also most health system CEOs in academic medical centers. And it's the intersection of those hospitals and health systems, as well as the deans of medical schools and provosts that are trying to make these decisions. But like I said, there's a lot of nuances, but many similarities, and we can go to the next slide. And this next slide just basically says that, structures matter regarding how decisions are made. But the main drivers for how academics are supported in a medical school are sort of the below. So is there a clinical margin that can be used to cross-subsidize the academic mission, whether that's education or research? And unfortunately, in our academic institutions where many of us are practicing or doing research or educating, those dollars that are available from the clinical mission to cross-subsidize the really important research and education missions have been squeezed, and they're less than they were 10, 20, 30 years ago in many regards. So if there is funding to cross-subsidize, then how much is there? And then this is a really important thing as faculty, and again, I can come at this from my own laboratory and my own faculty position. But one of the things I always tell our chairs and center directors and institute leaders is how successful an organization is at limiting the need for cross-subsidy for the academic missions is really critical. And what does that mean? It means that all of us as faculty and staff have a responsibility to be enormously good stewards of the resources that are entrusted to us, because to the extent that we are good stewards of that, the cross subsidy can be less and we can get sort of the most ROI from that. Probably most of us are familiar with the statistic that says you need about 53 cents of every dollar that comes from the NIH to support a basic science laboratory. Some institutions are more, some are less. But how you think about getting that 53 cents to cover that additional dollar that comes from the NIH to be less is worth a conversation in the institution. And then some of the external factors we'll talk about in the equations above. Next slide. So this slide just really talks about medical schools. And, you know, again, it's something that I've been privileged to do over the last 11 years is lead the medical school here at the Medical College of Wisconsin. But there's about 160 liaison committee of medical education. So that's the committee that's sponsored by the AAMC and the AMA that allows individuals like myself to hand a piece of paper to those students that the first two speakers talked about a little bit with great substrate, but it allows me to hand a paper to them after their time here at the Medical College of Wisconsin that has the letters M and D behind their name after they've successfully completed that study. But really, as we're thinking about sort of research intensive medical schools, you know, less than 50% of those medical schools are really research intensive. And so balancing the resources that need to go into the research mission, the education mission is different. And medical schools are growing up now that have sort of different missions and different sort of structures. Some of them are more based on a tuition model. As we look at medical education here at the Medical College of Wisconsin, the tuition I receive from our medical students is about 2% of my $1.4 billion budget that I manage every year. So while it's important, dollars that come in the door, it's really a small amount of the actual funding that allows us to spend on medical students. And so I talk here about increasing community-based schools, and that's just changing the landscape a little bit. And we could talk more about those, but that's a different lecture for a different day. Next slide. So this is just a busy slide that sort of gives some of the models that are out there. We're not going to spend time on this, but again, how the medical school links with the hospital and health system, and how the physician practice links with the medical school and the hospital and health system is different across the landscape. And individuals like myself and Dr. Miner, who are dealing with this every day, these different kinds of constructs do change the way in which you sort of approach some of these funds flow for education and research. Next slide. So what I wanted to just mention on this slide is that sort of fully integrated medical schools and health systems have become more of the norm, and that previous slide sort of gave that. But and this is where the dean of the medical school is also the leader or one of the leaders of an integrated hospital system and faculty practice plan. So here at the Medical College of Wisconsin, the faculty practice plans, they're all employees of the Medical College of Wisconsin. All of the resources run through the medical school. And we have a fairly well integrated health system, our children's hospital and our adult hospital. We share a margin with those hospitals. We do strategic planning together. We do actually have separate tax ID numbers. So we're not the fullest of integration. But so as you move along that continuum of integration, it does make the decisions easier in some regards about sort of how much money you are going to use to cross-subsidize education and research. But the fundamentals are still the same. Even if you have a single leader, the dean is the leader of the medical school faculty practice plan and the health system. There still are fundamentals that are the same, which is, you know, how much resources can you afford to do, and how do you balance the need to grow your clinical programs with the needs to grow your education and research missions. What I like to say, as I've sort of biopsied many of the academic health systems and medical schools across the country during my leadership roles is that people matter. The leaders of the least integrated system can make things work if they have a great relationship, and the leaders of the most integrated system can make things fail if there's a poor relationship. So really personalities matter, and how people get together matters. Economics matter as well. If the pie is growing, a lot is possible. There's a lot of mergers and acquisitions going on now, and most of our academic health systems, we spend as leaders of those academic health systems thinking about mergers and acquisitions, because as that pie grows, it does allow you more opportunities to support the really critical education and research missions that exist within your medical school or health science university. Next slide. So I don't think I'm going to spend really too much time here. I've sort of gone over the differences between the different structures, and this could be an hour or 2 hours or whatever conversation in and of itself. One thing that is interesting, though, is that final bullet under the comprehensive university system. And, the School of Medicine and academic health system are often viewed as a revenue stream for the university, and oftentimes make up some of the largest revenue that's there in the university. So it's an interesting paradigm that has shifted from, let's call it the 1960s, where large practice plans and large, relatively profitable academic hospitals were not the norm in universities and medical schools at the time. Next slide. So, the level of potential cross-subsidization that exists has declined, and I sort of mentioned that the commercial insurance premium for academic health systems decline. There's also been increased competition from non-academic systems that they compete at community rates for payment, and it has driven the necessity for academic health systems to sort of compete at lower rates. And also there's some blurring of the lines between academic and non-academic, primarily in the UME and GME areas, but many of the other health systems that I would consider sort of non-academic have brought in education missions, and a really large health system in California, like Kaiser, now has sponsored a medical school. They generally see that as a pipeline for physician workforce, but it has blurred some of these lines. Next slide. I talked a little bit already about mergers and acquisitions. The main point to make on this slide is that as we have grown our academic health systems, so say you move from what we like to say the hospital downtown, or the main teaching hospital, and let's say that there's a revenue in the $3 billion range for that main teaching hospital. As we've brought in other community hospitals, satellite hospitals, and grown health system sizes, and we've done this, we've doubled the overall scope and scale of our academic health system. It isn't necessarily the same. So the ability to cross-subsidize the education and research missions, if you go from a $5 billion to a $10 billion health system, is not necessarily the same. My most recent example is our recent acquisition of a smaller $500 million health hospital in a little bit north, a couple of hours north of here. We acquired that hospital for a clinical reason. We needed it to be important for our integrated clinical delivery, but we acquired that hospital with a negative margin. So the academic faculty would ask me, well, why did you do that? You have now taken some of the dollars that you used to be able to cross-subsidize the education and research missions, and now you're needing to use that money to cross-subsidize this non-profitable hospital that isn't even in our geographic location. The simple answer to that is we're going to make that hospital profitable within 12 months. But anyway, it's an interesting conundrum, and what I will say is that hospital won't reach the same profitability that we do down here on the main campus. Next slide. So, again, this is something that's real. And I know many of you, most of you probably feel on this slide that the reduced productivity has increased work review expectations for School of Medicine faculty. It's decreased productive time for academic faculty, and it's created shorter runways for faculty to quote unquote make it in the academic perspective. And so, I think this is really important, and all the things that have been talked about already around mentorship and how you spend time with individuals and getting them from point A to point B. We've made that harder, and there's no question about that. Next slide. So this is just a slide to maybe say the obvious, which many of us know, but we do have to subsidize undergraduate medical education. I go to the students every year and tell them about their tuition increase, which has been modest during my tenure as dean, but it costs about $125,000 a year to teach a medical student. Our tuition here is under 60 grand a year, so you can do the math. And as we heard in the first talk, we've moved from these mostly lecture-based format 100% all of the time to much more small group interactions, active learning. We use a combination of those, but it's expensive, and GME, most of the analyses would say, while there's some subsidy that has to happen in GME in longer programs, especially like otolaryngology, by the time somebody reaches their 5th year of training, or certainly if they do a fellowship 6th, 7th year. I was a slow learner, so it took me 8 years to finish my clinical training. Yeah, I mean, by the time you get to be a senior resident, those are actually probably net revenue positive. Next slide. So again, the most expensive thing to protect, though, is faculty time, research faculty time, education faculty time. There's not a guarantee of revenue from grants when you protect this time. Whether it's teaching or research, our faculty are expensive. I mean, they're if you're protecting 50% time for a clinician scientist in otolaryngology, you're subsidizing a substantial amount of time. That's even if they're a highly funded investigator, we know about the NIH cap. So this has been difficult, and even in things where we think like K awards, really protect a lot of time, those don't fully cover the cost. So it has made hard decisions about who do you protect and for how long. Next slide. So just some decision influencers. I think the culture of the organization is critical. I think you need to understand the strategic plan of your institution. We developed a research and education strategic plan, which we're implementing. We're growing our research missions through a lot of fortunate things that we've been able to do here financially. How does that plan fit in with the comprehensive university plan? And how is the School of Medicine and academic health system revenue segregated from the university? These are really important questions that really help to determine how much you can invest in your faculty, in education and research. And I mentioned this already, but under this strategic plan, I personally think that having a clinical translational science institute funded by the NIH through NCATS is critical. I'm fond of saying here, we've had a grant that's been funded during my entire time as dean and a little bit before that all real academic health systems have a grant through NCATS. Only about 60 or so medical schools have continuously had this, and it does help you to fund your clinical and translational research and support the infrastructure. How do the medical school and the graduate school interface? That's a whole nother talk on itself. And then I would just say the MSTP program is really critical. We've doubled the size of our MD PhD program. That's what that refers to here at MCW during my tenure. These individuals who have sort of committed to these types of programs are critical for us to develop clinician scientists moving forward, and are really a national treasure in my perspective. Next slide. So, the room where it happens, we talked about the headwinds. And so what I would say is the institutions that are doing well and are able to support all the things we're talking about around education and research, they have a cultural commitment to making it a top priority. And you can tell where that is and where that isn't. And if your organization, your institution doesn't have that cultural commitment, it's going to be hard to support some of the really important things in the education and research missions. Choices, most places can't do it all. Lloyd could give a perspective, I'm sure, about Stanford and some of the top 20 research intensive medical schools around the country, which do really cover the watershed. But I'll tell you, here in Milwaukee, we can't do it all. So we have to make choices about where we are and what we're going to invest in and how we're going to succeed. I mentioned our MSTP program. That's been an area of investment. How much dry versus wet lab do you want to have in your research program? Obviously, dry lab is less expensive. And then how do you link it to the clinical enterprise? That's often a way to get the CEO of the health system to agree to support more in the academic side around research and education. And I have some examples there. I just recently had a conversation with our health system CEO about a new family medicine residency program that we're going to start in the Latinx community here in Milwaukee. And there's actually a clinical benefit for the health system in doing this. So for somebody who's thinking about this in the leadership role, how you make those connections to the ROI and the clinical benefit can be important. Next slide. Oh man, there's a lot here. I think business acumen. When I started in, in medicine and science, it was sort of a different game, and really, it's changed a lot. And so, having strong business acumen in your school of medicine and your academic health system is critical. I talked about this problem of how long it takes and who you support. So again, I highlight the MSTP programs, and I won't delve into this, just getting sort of late on this talk. Let's go to the next slide. And then all of these are external factors which impact how you can do. Obviously, I'd be remiss to say that the pandemic hasn't changed some of the things that we've done. I've mentioned some of the market forces. Federal and state support can go up and then go down. We know of the wasteland of the stagnant NIH budget that was there for 11, 12, 13 years that really impacted our research missions. State-sponsored initiatives can really be important. And then endowments are critical. So how is your school, how is your institution doing on endowments? We've increased the endowment in the medical school since I've been here in 11 years by about $800 million. And that's just for the medical school. And so when the faculty asked me how we're going to support research and education, having increased the endowment by $800 million in a decade is how we're doing it here at MCW. Next slide. This is just another aspect, a nod to development campaigns, which are critical. And as we get shrinking of the dollars available, these are going to be more critical for institutions to succeed. Next slide. And so I thought I had one more, but I guess I don't. Just want to thank the faculty and staff and students here at the Medical College of Wisconsin. As I always say in meetings, it is their work, it's their endeavors that make all of this possible. The leaders get to make some decisions, but it really is their incredible work, their ethic towards that, and their creativity that allows us to do good things here at MCW.
Joe, thank you so much. What a wonderful talk, and a very complex topic that many of us don't think about on a day-to-day level. We have one question here so far, and I've got a couple of, thanks for this talk, very insightful and good information to keep in mind. My question is, should physician scientists applying for residency programs strongly keep in mind the type of health system? Is the structural organization of all institution or healthcare systems public and easy to find? Or do students have to do some digging or research on their own?
So, what I would say is for somebody who's a clinician scientist applying for their training program, what you want is you want to make sure that there's a commitment to your period of study, right? So if you're coming someplace and your goal is to, as an early faculty member, have a K08 award, to understand how the organization or the department supports those individuals is critical. But I think early on in your residency fellowship programs and even early faculty programs, probably the overarching things that I'm talking about here maybe aren't the only things you could consider or should consider. But I would say as you move from that early time to a faculty position where you hope to spend hopefully 10, 15, maybe 20 or 30 years of your life, understanding the economics of the health system, the medical school, some of the things on this slide are critical. I'm amazed actually with the lack of acumen, even at the chair level, when I'm interviewing chairs or center directors. The questions that people do or don't ask me, oftentimes they don't advance very far in the search process if they aren't savvy enough to understand what questions they should ask on that. But really as a faculty member, you want to understand the research strategic plan for your institution and how well set up that organization is to be able to weather a storm, rather than somebody coming to you and saying, well, we recruited you here, but guess what? Your resources that we promised aren't going to be there.
Yeah. Another question here. Endowment income may not be predictable. How do you budget strategically for this?
It's a good question. I would say endowment income, the way we do it, is really predictable. So we base our endowment income on a rolling 20 quarters average. So we do not go up and down with the stock market on any given week, month, or year. We use 20 quarters to identify what our endowment income has been. And what I'll say about predictability, in my 11 years as Dean of the Medical School, our philosophy around what we make available from the endowment income has not changed more than 0.2% So we've been between 4.2 and 4.4% in what we allow to be spun off from the endowment. Buried in that is we're not Pollyannish about the returns that we can get in the stock market, right? We do a good job of investing, and our returns on our investments are more in the 6 to 8% range, but we don't get out over our skis. We have a relatively more conservative payment plan for our endowment.
Thanks. I think there's one last question. I know it's going to go over a minute or two, but it's worth it because I know this is on the mind of almost every academic faculty member. How are academic medical systems tempering the ever-increasing demands on faculty to be more productive? Expectations to increase service, revenue, mandatory training, administrative work, teaching, and mentoring continue to increase, despite having more limited resources and being in the midst of a pandemic. At some point, one cannot keep doing more work and balance this with a home life. This is especially a concern for early career faculty who have less experience juggling all of these responsibilities.
That is an hour-long or more conversation. I'll just say a couple of things, which is I'm involved right now with the National Academy of Medicine work with the AAMC on well-being. And so what I will tell you is there are ways to think about the future that can be better. So some of you may know, many of you may, in January of this year, the CMS Medicare changed the way in which we document as physicians for Medicare patients to make it easier, to make it less onerous, to reduce the amount of screen time that a clinician has to spend in front of the computer, or pajama time doing their documentation. We can have a conversation about whether that's been effective or whether it will be effective. The data would suggest that it's been modestly effective, but just things like that, like the leaders of your organization, I hope if you ask them a question about what are you doing to reduce click time for me on my EHR and things like that, there should be some bodies in your organization that can answer those questions. Because those are some of the solutions that will be there. The other side to this is what I will say is, I think most of us have sort of gotten past the idea that people have to be the triple or quadruple threat, right? So you need a very broad group of people. It takes a village. So some people are going to be clinicians, and hopefully if they join a medical school faculty, I talk about this all the time, they'll understand the importance of research and education. They may be full-time clinical, but they're willing to have a little bit of their sort of clinical revenue go to support those really critical academic missions. And then I would say that, and this is the most critical, especially given that we're at ARO and talking about otolaryngology, it is critical that the young people who are on a scientific pathway get protected time. And I mean real protected time, not nights and weekends, I'll never forget somebody who came up to me early in my scientific career and said, well, you got a lot of time on nights and weekends. Nope, it's not nights and weekends. Yes, you can spend nights and weekends, and all of us that have had a successful scientific career have done that, but you got to protect those people that you're investing in, or they won't succeed.
Joe, thank you so much. That was a wonderful talk. And like you said, it could go on almost all day, I'm sure. Thanks again. Let's go to the next speaker. I'm just going to introduce Lloyd Miner. I think probably many of us know Lloyd. He's the Carl and Elizabeth Naumann Dean of the Stanford School of Medicine. His book, Discovering Precision Health, published in 2020, illustrates how Stanford medicine and other health leaders are revolutionizing biomedicine. Lloyd is also a professor of otolaryngology, head and neck surgery, and a professor of bioengineering and of neurobiology, by courtesy at Stanford University. His research experience is in balance and inner ear disorders. He's a past president of ARO, and in 2012, he was elected to the National Academy of Medicine. Lloyd, I just want to thank you for coming to talk today. And I asked you to speak about nurturing the budding physician scientist, because I think you've been exceptionally successful at this throughout your career. And I want to learn from you.
Well, thanks a lot, John. It's great to be with you, and congratulations to you, John, for being president of ARO and on your leadership and the great research that you have done and are doing. So it's an honor to be with such a distinguished group of panelists this morning and to share a few thoughts about mentorship and training of physician scientists, and maybe a few thoughts also about the future of life sciences research and its impact on health. If you could go ahead and project the slides, please. Thank you. So could we bring up the slides, please?
Let's see.
I think they're uploaded. Yeah,
Oh, there they go. Yeah.
There we go. Thank you so much. Next slide, please. These are my disclosures and my interactions with industry, but nothing I'm going to talk about today is related to these industry interactions. Next slide, please. So I had the privilege of working with an extraordinary mentor, and a lot of my thoughts about mentorship, and certainly my my scientific background and whatever accomplishments I made or have made are attributable to the time I spent with Jay Goldberg. And I maybe a little bit about my history would be helpful in understanding how I approach mentorship and thoughts about scientists. It was actually as an undergraduate in a course in bioengineering that I became interested in the vestibular system. And I just thought it was, and still do, think it's an incredibly elegant system. And I love the way that relatively straightforward math and systems analysis could be used, not only to describe the vestibular system, but to really understand how it works. And of course, at the time I was training, really, Jay Goldberg was the pillar of the field, and in so many ways defined, particularly for the physiology of the periphery, defined the principles that still underlie the field today. And so I made the decision that I wanted to work with him, and fortunately he accepted me in his lab. Jay's approach to mentorship was fairly hands-off. He didn't have he never had a large lab. He actively collaborated with Cesar Fernandez, who was also a brilliant researcher. But he had an uncanny ability to know what was going on, not to solve problems for those working with him, but never to let them go completely underwater. And I think that's really important. It certainly taught me how to think independently, how to design, how to construct a project, how to design a set of questions that can then be addressed experimentally, and then finally how to pull together the data, including in those days, we didn't have the type of software for analyzing spike trains and other things that we have today. So it's a lot of hands-on, actually making the experiments work, but also developing the techniques of analysis. And I think that really, that level of preparation is still really important for people who want to really do independent science and make fundamental contributions. Jay was mentored by two previous ARO Award of Merit recipients. Of course, Jay was a recipient of the ARO Award of Merit, and many of Jay's proteges and trainees have received the ARO Award of Merit too. So his impact continues in the vestibular and auditory fields. Next slide, please. Now, there is a shortage of physician scientists. We've all heard about this. The numbers are that we've, over the past decade or so, gone from roughly 7,000 physician scientists in their 40s to now 4,000. So if we're going to catch up, that means we need to train incrementally an additional 200 physician scientists per year. And of course, that occurs in a time when, as you heard from Joe Kirschner and others, it's more and more challenging to fund and to really provide the type of support that people in training need. Biomedicine has become an extraordinarily complex endeavor. And I spent 11 years after medical school training before my first faculty job. And, I don't regret having spent that time. There's some things now, residencies are shorter than they were before. For me, it was 6 years in otolaryngology residency and then a year of fellowship after that, plus 4 years of a postdoc in Jay's lab. So there are some ways that we can make the training and should make the training more efficient, but it is a long pathway, and how we then support people and nurture really the enthusiasm, the curiosity, and the drive and the passion that it takes to wear two hats and have, in essence, two careers. How we do that more effectively, I think, will determine how successful we are at increasing the pool of clinician scientists, physician scientists. The other thing, and it's been mentioned before already this morning in this symposium, is the need in the biomedical workforce. The needs are changing somewhat. The quadruple threat, it's harder and harder to achieve. But even if one takes a segment of biomedical research, increasingly the lone researcher doing great work in a lab with trainees and having some collaborations, that model is in some areas still very important, but it's being challenged in a lot of other areas, in that biomedical research today is so interdisciplinary and is becoming even more interdisciplinary. And I'll say a few words about that, towards the end of my remarks. Next slide, please. Well, then what do we do? How do we broaden the pipeline? In so many respects, this is the century of the life sciences. I think most of us had that perspective before COVID, but if there was any doubt about it, I think COVID removed that doubt. We've been brought to our knees by a single-stranded RNA virus that has dominated the world sphere now for almost 2 years. Our understanding of the immune response to that virus, to the vaccines that fortunately were developed due to a lot of discovery-based research, and then due to some very inspired investments made by the U.S. government, we were able to have among the most effective vaccines that have ever been developed. But it's just underscored how much we have to learn about viruses, for sure, about vaccines, and in general about human biology. So we need to broaden the pipeline, and that has to begin earlier than we thought before. And we're doing a number of things here. We have several high school programs where we bring students in over the summer when we're not in the midst of a pandemic that's challenging the way our labs work, but bring students into labs over the summer to work firsthand. Our medical school curriculum is very much geared towards training physician scientists. We have very consciously not gone to shortening the preclinical years. We still have 2 preclinical years. In fact, for students who wish to lengthen the preclinical years, we provide a number of different methods for them to do that. We have a program called the Berg Scholars Program, named in honor of Paul Berg, who, of course, won the Nobel Prize for recombinant DNA. Paul is still very active and feels very strongly that we need to increase the pipeline of physician scientists. So students can broaden out their medical education. We have the benefit of being an academic medical center very much integrated within a great research university. Our academic medical center is centered at the university. And for the first 2 years of medical school, we follow the same calendar as the rest of the university. So we have first year, second year medical students who are taking courses in computer science or in the law school, and about 15 to 20% of our students get a concomitant MD and PhD degree. We have others that are getting degrees in business or other areas of the university as well. And I think that's important because leveraging those different skills and disciplines is really going to help to drive the future of life sciences. It is going to be this convergence, in particular the convergence of biomedicine with information sciences and technology, that I think defines the future of life sciences and its impact on human health. We've also revised our curriculum in the medical school, the preclinical years. It is, as I said, a scientifically intensive community, and we really don't make a curriculum. We don't apologize for that. We explain, in our information that we furnish to all of our students that we do have a scientifically intense first couple of years, and we're constantly looking for ways to improve the way we teach science, certainly the science that is considered relevant for the practice of medicine today, but also the scientific understanding and methods that will hopefully define the future, so that we actually are training a generation of lifelong learners as physician scientists. Next slide, please. I want to spend some time talking about diversity, equity, and inclusion, because I think it's critically important that not only do we have an increase in the workforce of physician scientists, but we absolutely need a more diverse workforce of physician scientists. And to achieve that, we're going to have to be very intentional about the programs and outreach activities that we do to achieve a more diverse cohort of people who become physician scientists. I feel very passionate about that. I really want that to be one of the legacies that I leave behind here at Stanford, and also for the nation, if we can serve as a beacon in the programs that we're initiating and the activities we're founding. I want to talk about one of those. We were fortunate to get a very generous philanthropic gift to found a series of programs that we go by the acronym of REACH, or Racial Equity to Advance a Community of Health. And over the next 5 years, about 700 trainees from underrepresented backgrounds in medicine, so underrepresented minority students, first-gen students, about 700 students at various different levels of their training are going to benefit from the programs we're starting under REACH. For example, we're starting a post-bac program, a post-bac program that students maybe want to go to medical school can enroll in, but more fundamentally, students who want to do science and who come from a background or an undergraduate experience where perhaps they haven't had the opportunity to be exposed to the real cutting edge of biomedical science. So and all of these programs are fully funded. We'll bring students in for a year. There'll be a didactic curriculum. Each of them will work in a lab and spend roughly 50% of their time in a lab. We've chosen the mentors carefully to be mentors that really enjoy and are really good at mentoring students. And we hope that many of them will either enroll in PhD programs, in our PhD programs or others, or perhaps MD, PhD, or MD programs. But really the focus is on learning about science, what it is, how it's done, and to attract people who might not have thought about being scientists or physician scientists, but who were given the exposure and the opportunity, get the bug and see that they really would like to make contributions. Our medical school, we've been able to, our classes have become much more diverse now. About 32% of our students are from groups underrepresented in medicine. That's roughly double what it was 9 years ago. And again, thanks to another very generous gift, we are now a loan-free medical school with the entering class of 2021. All of our financial aid is need-based, but for those students with maximum need, we do not include loans in their packages. The financial aid packages are all grant-based. So no student from this point forward, and we have the money to get it started, but it's still one of my most active areas of fundraising. No student will incur additional debt over what they've incurred as undergrads to go to medical school. Their medical school education will be taken care of to the extent of their financial need. That too has helped to diversify the pool of our students, and I think enable students to have the type of educational experience that I hope we offer that might not otherwise have come because they would have had to take out a lot more loans. Next slide. So some tenets of mentorship. John, you made some very kind remarks and about my mentorship of people who've gone on to do amazing things. And I want to say first that I have learned far more from the people I've had the privilege of mentoring than I'm sure they've learned from me. And that was one of the true joys of my professional career. I mentioned that I spent 11 years training after medical school before my first faculty job. My wife often asked if I was going to get Social Security before I got a real job. And starting at Hopkins in the fall of 1993, I was fortunate to attract first some residents, then some fellows. And I really, really loved working with them. And I'm confident I learned more from them than they did from me. But it was just such a privilege. And I hope that I have contributed to their success. They've been remarkably successful. And it's really what got me interested in other areas of leadership. Because, you know, if we think about our tripartite mission of research, patient care, teaching, the patient care impact that we have is remarkable. It's immediate and it's individual, right? And for those of us who have the privilege of taking care of patients, there's nothing like seeing the benefit of our knowledge, of our skills as a surgeon, benefit the individual patient. So that's, you know, a physician or a surgeon benefiting an individual patient. The research we do can have we can start new fields. And in my case, fortunate enough to define a syndrome, superior canal dehiscence syndrome, that many people have benefited from having surgical correction. And so that generalizes. But the exponential multiplier is in mentorship. The exponential multiplier is in our educational programs, because a person who is successfully mentored or grows and builds their career in an environment, then goes out and mentors others, and they go out and mentor others, and there's an immediate exponential effect. So the real long-term impact that we have as physician scientists at medical schools, academic medical centers, the real long-term impact comes more from our educational opportunities than it does from any other aspect of our mission. And I think that's just important to keep in mind. It's oftentimes an aspect of our mission that gets neglected. It has a challenging business model, as you heard from Joe, but it is the way we have enormous impact. So to be a good mentor, I think treasuring the interaction that you have with the people you're working with is the start. You know, being careful about who works with you. There has to be a chemistry between individuals, and there's not a right or wrong to that. But also, I've always tried to look for people that would challenge me and with whom I would grow from my interactions with them, as well as hopefully they would grow from their interactions with me. It's certainly okay not to know all the answers. I think teaching time management or exemplifying good time management is really important because of the complexity of having, you know, multiple careers in one person. And finally, you know, hopefully the passion that each of us feels in the work we're doing rubs off on the people who are working with us, because it is that passion and that drive that sustains all of us through the vicissitudes and the ups and downs of having an academic career in biomedicine today. So next slide, please. Now, I want to close on a point that Joe mentioned in his closing as well, and that is, how do we support our people? And that means supporting our mentors. That was important before COVID, but it's particularly important because of COVID. The effects of COVID on the healthcare system are enormous, and we're only beginning to grapple with their long-term effects. People, our people, our physicians, our staff, our nurses, administrative leaders, have worked under incredibly stressful conditions over the past 2 years. More uncertainties than we've dealt with. There was one of our faculty is a good friend with General James Mattis, who is now on a senior fellow at the Hoover Institution at Stanford. General Mattis emailed him early in the pandemic and said, take care of yourself. Let me know keep in touch with me. I'm thinking about you. I support you. And then his last sentence was, remember, this is what you trained for. And I thought, and this faculty member thought, for a general to say that, yes, that's what you say to your troops before you go to battle, because they have trained extensively. I don't think any of us trained for COVID, not even remotely. And certainly we as a nation, we as a medical profession, were not at all prepared for a pandemic. And so dealing with these effects and helping our people work through those effects and supporting each other is going to be important for years to come. We did establish, now it's been 6 years ago, we were the first academic medical center to establish the position of a chief wellness officer. And we recruited Tate Shanafelt from the Mayo Clinic, who has led that office. And so we had a number of programs in place to support our people before COVID. And of course, we've accelerated and built those programs even more during COVID. But I'm very much aware that we still need to be doing more, and that perhaps the best thing we can do is to be great listeners, to be compassionate, and to look for opportunities to help in any way that we can when we can. That's going to be important for years to come. So if you can turn the slides off at this point, and would be happy to open it up for questions or feedback.
Lloyd, thank you so much. What a wonderful talk. And there's already several questions out here. I'm going to just ask them one by one here. As biomedical research becomes big science with multi-author papers, do we need a new metric for measuring career progress or future promise?
Yeah, it's a wonderful question, and physicists have dealt with this for years, right? High energy physicists. If you look at the key papers, they have 100 or more authors. What's really important is that for career advancement, and as we're looking at tenure and promotion, is at the beginning of a project that's going to be a multifaceted, multi-authored project, define the role of each investigator very clearly. And increasingly, there are many journals that ask for those roles to be specified in the publication. That's what we look for when we're doing tenure evaluations. I think the notion that, well, you can't collaborate, that's wrong. You can collaborate, you should collaborate, but your individual contribution to the work has to be definable, and others have to remark and comment and evaluate it. So that's really important. And where I think we have problems is when that's not done. And then at the end of the day, you don't know, well, what did this person actually do in that? But the notion that we should be discouraging team science or collaboration pre-tenure, I think is wrong-minded. It just means you have to be very intentional and careful about how you set up the parameters and define the roles.
Thanks. Thanks for a wonderful talk. What do you think was the most impactful lever to achieve Stanford Medical School increase in medical student intake diversity?
I think there were a number. I don't think it was a single one. Our admissions office before COVID was not that dissimilar from an undergraduate admission office in the sense that we go out to colleges and universities and start meeting with students as sophomores, juniors, and we actively seek out students from underrepresented backgrounds. We also have a number of summer programs because many students from the East Coast, they've never been to California, and they're great students. They're going to get into the New England, East Coast medical schools, and it's Stanford. Well, that's a long way away. So, reaching out has been important. I think having the additional scholarship support has been important, and just saying that one of our goals, one of the things we're holding ourselves accountable for, is to be a more diverse community than we've been in the past.
Yeah, the palm trees help.
We like to do visits in February, bring people out in February.
Let's see here. On the question of diversity and equity, oh, this is a little bit off, but that's okay. It's still a good question. The salary level of support staff can be simply too low to provide a middle-class life. These people may be part of a union, so it could be a hard problem, but it's the question of equity in terms of more reasonable pay should be extended to these essential work mates. So what is the role of medical school leadership in addressing this problem?
Well, it is a big problem. It's particularly a problem in an area like ours where the cost of living is so high. And we've done a number of things, and we did just across the university increase base pay by 3%. That will become effective in March, but made this mid-year adjustment based upon the financial impact of the pandemic and other factors. I do think pay equity is exceedingly important, and how, you know, that's something we're addressing. I know our peer institutions are as well. Also looking at how we can do hybrid work. People who live remotely then don't have to be traveling in perhaps every day. So there are a number of things there that I think are important for us to do and continue to do.
Yeah, thanks. That's a tough one, especially with the COVID impacts on the health systems.
Yeah.
Okay, I think we've hit 9 o'clock, and I think, thank you, Lloyd.
Thank
What
you.
we're going to do now is take a 20-minute break. Well, it's 9 o'clock Pacific time, I should say. So at 20 minutes after the hour, we will come back to finish up the symposium. So everybody can take a short break. Thanks. Allie, what do you think? Should we go ahead and get started?
Sure do. Here we go.
Okay. Well, let's see, we got the slide going. There we go. Well, welcome back, everybody. So we're in the second half of this presidential symposium. And again, I just want, if you weren't here for the, when we kind of kicked things off this morning, I just want to welcome everybody to ARO. As I said, I wish we could have had it in person, but at least we're having something virtually, and we were able to convert online reasonably quickly. I think mostly because of the expertise of our management group, Parthenon, which I thank tremendously. As well as, of course, the program committee led by Matt Kelly, who had to do a lot of last minute changes. Looking at the symposium speaker list, you might notice that there's kind of a West Coast bias here, and I apologize for that. I did this on purpose because I was a little worried that people might not be able to come to the meeting when I was putting this together. And so I tried to pick people that were more local and could, have the best chance of coming in person. In the end, it didn't really matter, did it? But this is what we got. And luckily we got experts in the field. And so it's been a wonderful symposium so far. I've learned a lot. I've been taking notes. And I'm excited to introduce Chris Manning. So he works with me here at USC. Chris joined the University of Southern California just last year as our first Chief Inclusion and Diversity Officer, after serving as both an assistant and associate provost for academic diversity for 5 years at Loyola University in Chicago. In addition to his administrative experience, Chris was an associate professor of history at Loyola since 2008, teaching subjects such as Black history, the Civil Rights Movement, Black politics, and 20th century American history. His research is focused on the ability of ordinary people to strive for social change. And at USC, Chris is responsible for building strategies, programs, and initiatives that reinforce its commitment to inclusion, diversity, equity, and belonging, and to address ongoing challenges of discrimination and bias. I've gotten the chance to meet with Chris since he's been here. He's an amazing individual, very detailed, and has already given me terrific advice on things to do to improve DEI efforts in our department. And so, Chris, I want to welcome you and thank you for speaking to our group today.
Thank you. I'm really happy to be here. Chris Manning, he, him, his, the Chief Inclusion and Diversity Officer at the University of Southern California. And I want to thank all of you, all the members of the Association for Research in Otolaryngology, as well as Dr. John Ogilvie, for inviting me to present to you all on this critical topic, mentoring, recruiting, and training diverse scientists, what works. So let me share my screen. Okay, what works? We're going to go over a few things today. First, I want to confirm the necessity of the work, even though I know that you've done a lot of that already today. Then I'd like to review some best practices in mentoring. And then I'd like to take a look at some programs that combine mentoring and recruiting practices to widen the pipeline of diverse researchers in STEM. So to get us all on the same page, let's first make sure we have an understanding of the urgency. Although racial and ethnic minorities make up approximately 39% of our population, they only make up 9% of STEM PhDs. The Latinx population in particular is underrepresented in STEM by 50%. And while, as far as we've come, women in STEM still continue to make less than men across all so-called racial groups. Now, these and other alarming data points have some real ramifications on how work is done. According to a 2019 study published in the Journal of the American Medical Association, the typical cancer clinical trial was about 76% white, while Latinx and Black subjects made up only 6% and 3% respectively. Also, to a certain extent, this next one, COVID and pregnant/lactating women, actually touched on my life. A 2021 European Heart Journal study documented how both the Pfizer and Moderna mRNA vaccine trials excluded pregnant and lactating women, even though there was no evidence to suggest that the vaccines caused any malformation of embryos and no plausibility that they were transmitted in breast milk. And how this affected me personally was that my wife, who was a nurse who worked in community health in Black and Brown populations where they were suffering from mental illness, was pregnant at the time. And she agonized for much of 2021, particularly the winter and the spring, about whether or not to take the vaccine. Ultimately, the lack of information on vaccines led her to leave her job rather than risking affecting our baby. And this anecdote was not uncommon. A February 2021 study in the Journal of Perinatology found that women in healthcare who were trying to conceive were 3 times more likely to delay and decline the vaccine, while those who were pregnant were 6 times more likely to delay or decline. Imagine the emotional tumult that women experience who are trying to make this decision because of this research oversight, not to mention the significant impact it had on their healthcare system, which depends on women professionals. Interestingly, we also see this in the technology, in medical algorithms that are utilized for evaluating patient care, and everything from who receives heart surgery to determining who gets a kidney transplant to determining who should have a vaginal birth. All of those medical algorithms have been shown to be racially biased. For example, an August 2020 study in the New England Journal of Medicine described an algorithm that assigns 3 points to any non-Black patient at risk of heart failure. Now, more points mean a higher risk of death, meaning a higher likelihood of being referred to specialized care. The article went on to describe how at one Boston hospital, Black and Latinx patients arriving in the emergency room with cardiac symptoms were thus less likely than white patients with the same symptoms and medical history to be admitted to the cardiology unit. And lastly, we also see this impact in funding. Sickle cell disease, for example, primarily affects Black Americans, while cystic fibrosis primarily affects white Americans. Nevertheless, according to the Minority Coalition for Precision Medicine, fewer individuals in the United States are affected by cystic fibrosis compared to sickle cell. Yet national funding, research, new clinical trials, and new drug approvals are widely disparate between the two conditions. So we can see that a diverse medical and scientific workforce is critical to ensuring that the knowledge available to future healthcare providers, researchers, and policymakers will be informed by diverse scientists who are most familiar with the needs of a diverse population. Moreover, it's important to diversify STEM to compete globally, to create better science through enhanced innovation, to provide role models that can encourage an expansion of the scientific enterprise, and to contribute to America's ongoing saga of social justice. Or the way I like to think about it, to be on the right side of history. So now let's talk about the next item on our list, mentoring. I really love this quote from the 2016 Presidential Awards for Excellence in Science, Mathematics, and Engineering Mentoring and American Association for the Advancement of Science Mentor Awardee meeting. Quote, mentoring is about creating an inclusive environment that makes students from all backgrounds feel like they belong in STEM, unquote. So how can we do that? First, it's good to make sure that we stick to some best practices in STEM mentoring. When creating mentoring programs, give considerable thought on how you're going to vet future participants. In the application process, for example, make sure that you seek evidence that potential mentees have a desire to do research in otolaryngology. Ask deep questions and try to understand their motivation for being a part of this field. But don't just stop with the mentees. Create a similarly rigorous application process for mentors. Make sure you can understand whether mentors really have a desire and a dedication to advancing the field through diversification. After getting the applications, Screen potential mentors and mentees for commitment, availability, and openness to a mentoring relationship. Make sure your application materials ask some really good questions like, have you had a mentoring relationship before? What are your expectations in a mentoring relationship? And this is a tough one because a lot of people will say they want to be a mentor, but you should also ask, what is your weekly, monthly schedule? Or how will you make time to engage with your mentee? Another good question to ask is, before we match you, are you willing to engage in training on how to make the most of the mentoring relationship or on how to be a mentor? It's very important to get confirmation on this one because mentoring is a skill, not something that just happens by accident. Speaking of accidents, make sure that you don't assign people randomly. I think many of us may have had the experience of having a mentor randomly assigned to us before. It's often awkward. You don't have anything in common with this person, and the mentoring relationship can fizzle. Rather, minimally, try to match people considering individual characteristics. And I would, in particular, suggest a self-selection process, which I have been involved in as a mentor and which I have utilized in mentoring programs that I've run for faculty, and which I'm happy to talk about in the Q&A session. Moving on to number 4, make sure to provide structured activities and support for their execution. In other words, don't hope that just because you pair some people together, good things will happen. Instead, create a set of suggested and required activities. And for the required activities in particular, attach check-ins from both parties so you can make sure that you're seeing how the relationship is going. And along those lines, for number 5, make sure to measure overall progress at regular cycles, annually, semesterly, quarterly. It's quite possible that mentoring pairings don't work. And what you don't want to do is wait till you get to the end of a year, find out that a pairing wasn't the best one, and then lose both the mentor and the mentee because of a negative experience. So have some ways to regularly evaluate the program and determine if those two people are working together. And if they're not, you can reassign and reassess while they're still enthusiastic. Now, we know that across academic research, various enterprises suffer from pipeline issues, which is the production and flow of professionals that can join our various communities. So I'd urge you to think about the multiple levels which you and your peers can contribute to expanding the pipeline. From encouraging diverse students to consider a STEM career, to diversifying STEM students in higher education, to enhancing the excellence of your own departments through diversifying your community of research professionals. And so what I'd like to do now, getting to the what works part of the title, is provide you some examples of various programs that have worked at each of these levels that you can consider for yourself and your colleagues. The first one I'd like to talk about is Science Club. Science Club uses long-term mentoring to raise STEM interest among underserved middle school students and support the long-term pursuit of science careers. The initiative was developed in 2008 between Northwestern University, the Boys and Girls Clubs of Chicago, and the Chicago Public Schools. Every week, youth and mentors in small groups, 4 youth and 2 mentors, work on challenging hands-on investigations at a community site such as a Boys and Girls Club, Park District site, or YMCA. The groups are formed in an age and aptitude specific way, while the curricula lasts about 7 to 10 weeks and is about 90 minutes for each session. The curriculum was developed collaboratively by CPS teachers with Northwestern faculty to provide deeper exploration into scientific areas of strong interest to kids, from food science to biomedical engineering. Throughout, mentors receive professional development in multiple areas, including pedagogy, youth engagement, science communication, cultural awareness, and program design evaluation. And one of the things that's really beautiful about this program is that Science Club not only trains the scientists of tomorrow, it trains the scientists of today so that they can become better mentors themselves. Now, moving up to the high school level, I'd like to take a look at the New York City Science Research Mentoring Consortium. This consortium is a group of New York City academic, research, and cultural institutions that are committed to providing high school students from high potential, yet under-resourced and underrepresented backgrounds with mentored, authentic research experiences in STEM. The consortium provides foundational coursework to students to increase their comfort and competency when entering a lab, and it ultimately results in a more successful experience for both the student and the mentor. The consortium partners share experiences, expertise, and identify opportunities and strategies to effectively support youth in developing science research skills and competencies. The consortium also cultivates a model of community practice that creates a social network of scientists, graduate students, educators, and like-minded peers with shared values and research endeavors. Lastly, and important for building our pipeline, the consortium provides students with college and career readiness and support. At the undergraduate level, I'm really fond of the University of Chicago Charisma program that prepares undergraduate students from populations underrepresented in medicine and sciences to become clinical research leaders across health needs in an aging population. Charisma offers eligible students a variety of research training and clinical shadowing opportunities, including a curriculum focused on aging-related conditions, methodological approaches to studying conditions, a clinical research experience where students learn to recruit, consent, and interview patients, a faculty-mentored aging-related research program, and a clinical mentorship and shadowing program. And I know programs like this work because if you take a look at this old picture here, that guy in the middle is me in the Student Research Opportunities Program at the University of Chicago back in the 1990s. This was a similarly situated program for underrepresented minorities, encouraging us to be researchers in higher education. And many of us have gone on to get our PhDs or in academia. And we still call each other by our nickname, SROP kids, even though we're not really kids anymore. Another undergraduate program I'd like to point you out is the Louisiana Science, Technology, Engineering, and Mathematics Research Scholars Program. This program provides the opportunity to enhance academic experiences and for underrepresented students to develop as leaders both at LSU and within the research community. The program offers multifaceted training and employs a holistic development learning approach that includes an intensive summer bridge program, generous financial support, a scholarly community, learning strategies to increase undergraduate success, especially in the so-called weed out classes, automatic admission into the Honors College, peer and faculty mentoring, research opportunities during the academic year and the summer, at both LSU as well as other institutions, and professional and leadership skills development. Lastly, and getting closer to where we are today, training in the skills needed to apply and succeed in graduate school. At the graduate level, one of my favorite projects is the University of Texas El Paso's Puentes project. Now, faculty mentoring of students and postdocs is an important part of UTEP's commitment to access and excellence in higher education. And the Puentes project recommended that graduate students and postdocs actively seek mentoring relationships with faculty at not only at the University of Texas El Paso, but in their field at other institutions. This is key because we know now that at the professional levels, rising practitioners need multiple mentors from varied positions in their field. We now advise the formation not of a mentoring relationship, but of mentoring networks for our young professionals. So students and postdocs in the Puentes project were encouraged to have multiple faculty members. They were encouraged to be introduced at meetings and research conferences to other people in the field. And mentors worked with their mentees to create individual development plans. Mentors and mentees both had opportunities to learn more about effective mentoring, which is a very interesting tactic rather than just focusing on the mentors, bringing them both together to learn about the relationship. And UTEP had this program called the Excellence in Mentoring Lecture Series. The series hosted recognized mentors from national research institutions as guest speakers, and they presented on general and discipline-focused talks. Post-event surveys showed that the graduate students found this series to be both impactful and positive, allowing them both to meet other students who had similar goals and academic experiences while getting greater understanding of the mentoring process. Faculty also learned more about how to mentor effectively. And additionally, this series strengthened the relationships by encouraging both parties to set academic and professional growth expectations based on what they learned in these presentations. Now, what's so great about the Fuentes project is that it shows us the importance of sustainability. The project was funded by a Department of Education grant. Yet when the grant ran out, UTEP was so committed to the principles of the project that 4 of its most impactful elements have been retained by the UTEP Graduate School. Particularly, they still conduct the Graduate School Research Expo. They continue the Graduate School Professional Development Program. They have research fellowships specifically for underrepresented graduate students, and they kept the support staff that was developed for this program. Last but not least, I'd like to give you some cues on how to sort of bring people in to your own institutions. And here, I would like you to think about pipeline relationships. Start by using the integrated post-secondary education system data to learn what institutions are producing high numbers of diverse graduates in your field. When attempting to create pipeline relationships regarding graduate school, look at the production of bachelor's degrees. And when attempting to create a pipeline for postdocs and colleagues, look at the production of graduate degrees. Although I think you'll find it's the same at institutions. Next, construct a national list of the institutions that you'd like to work with, and make sure you work your way through each of them, connecting to a range of offices. For graduate recruitment, start with individual department chairs and undergraduate program directors, which typically provide guidance to majors. Then reach out to career services in the fellowships office if an institution has one. For postdocs and faculty recruitment, reach out to the institution's graduate school. If the institution has a special unit for diverse graduate students, reach out to that unit too. As with the previous step, connect to individual academic department chairs, and in this case, their graduate program directors. What should you communicate in this outreach? Provide a high-level positive description of your institution. Focus on its positive qualities overall and the positive qualities of the local community. Think of this as a virtual postcard. You don't want to go too deep into the weeds. Then make sure that you can explain what your department, program, or lab has to offer. And then express how diverse candidates can contribute towards increasing the excellence of what you do, which is important to show that your intentions are authentic and not performative in nature. Finally, describe what you have done to make yourself a welcoming environment for diverse candidates. If an undergraduate program is a particularly strong match, consider creating a memorandum of understanding. These can vary in specifics, but the general contours include allowing students from a particular institution to begin taking graduate courses, maintaining a specific GPA, participation in a summer bridge program, and then automatic admission into your program. In closing, I'd like to leave you with a quote from a 2014 article in Scientific American by an African-American scientist named Kenneth Gibbs, a Stanford-trained immunologist, now at the National Institute of General Medical Sciences. In Western cultures, our narratives about science often focus on the singular, brilliant scientist who makes substantial contributions through their innate genius. However, scientific talent is not innate. It's cultivated through many hours of training and effort. Moreover, teams, not individuals, conduct most scientific research. Thus, the narrative of the brilliant individual scientist largely fails us in the modern research enterprise. When we consider scientific research as a group problem-solving effort, instead of individual brilliance, we see that diversity becomes the key to excellence. In his book, The Difference, Professor Scott Page lays out a mathematic rationale and logic for diversity. He shows that when trying to solve complex problems, i.e. the sorts of things that scientists are paid to do, progress often results from diverse perspectives. That is, the ability to see the problem differently, not simply being smart, is often the key to a breakthrough. As a result, when groups of intelligent individuals are working to solve hard problems, the diversity of the problem solvers matters more than their individual ability. Thus, diversity is not distinct from enhancing overall quality. It is integral to achieving it. Thank you, and I hope this has been helpful.
Chris, thank you so much. That's a wonderful talk. And again, as I mentioned at the beginning, so practical. It's very rare that I get specific advice points that I can like write down and then follow, especially for reaching out to institutions that train underrepresented students from underrepresented groups and how to reach out to them. One of the things you mentioned to me when we talked, well, maybe a month or so ago, was when recruiting these students from underrepresented group into the lab, we kind of need to treat them like they're these athletes that the university recruits. When you really go after them, and to me that meant a lot. I mean, when I think about how much they go after those football players, and we don't do the same aggressive recruitment tactics in science, and we probably should be.
Yeah, I mean, something to consider, and this is one of the things we're working on at USC. We're trying to conceive of it centrally, which is kind of difficult. But one things that labs and departments can do is they can begin to think of a practical and proactive strategy to reach out. A very easy one that's cheap is for individuals to maintain contacts from the institutions from which they graduated, contacts with their graduate program directors there, and say, we're really interested in improving the work that we do by diversification. We always kind of maybe check in yearly to find out if you've got some good students who are coming up, and you can get them early, actually. You know, a graduate programs director is going to know everyone that's coming through, and so you can begin those relationships pretty early. That's really low cost. You know, that's an email and a phone call. If you want to take it up a little bit, you could start allocating aspects of your budget for individuals to make recruiting trips. So for example, if IPEDS data indicates that Howard University or Fisk University is producing large numbers of African-American biologists who you think might be interested in a career in doing research in otolaryngology, take a trip down there. Go meet some of the students, introduce yourself, ask if you can give a talk, always demonstrating your commitment to diversification. One other thing to do though, but when thinking about the athletes, when they bring athletes in, they show off the facilities, right? You need to show off the facilities too. But by show off the facilities, I don't mean your research facilities. I mean showing off that you all have done the work such that if you bring someone in, they will find a comfortable home. I'll talk about a different field for just a moment. I remember working with a physics department that had one tenured woman faculty member for 20 years, and she was going to retire. And they were coming to me, talking to me about like, how can we recruit another woman faculty member? And I asked them, well, why would a woman faculty member want to come here? You were unable to find one person for tenure track for the last 20 years. I will help you do the recruiting and strategy, but you really need to think about the culture that you have here, so that such that if you find a young woman physicist, she would actually be able to be comfortable here. So show off your facilities, talk about the work you've learned to do, to mentor people, to not be microaggressive, to create an inclusive environment. And maybe even if you're not offering as much money in terms of startup packages, et cetera, they might choose you because that's a place where they can find a home.
That's a very good point. Thank you. I think we're basically out of time at this point. So Chris, I want to thank you so much for your wonderful talk today. And it meant a lot because this is such an important area, and we know in our field, we need to do better. And I know a lot of people are working on it. In fact, many of the people on the panel work really hard at increasing DEI within our membership. And so that'll be another area where we can talk about this. Chris, thank you very much. And I hope you have a great weekend.
Thank you. You all have a great conference.
Okay. Okay, so I've got a bunch of introductions to do here. So we're going to move on to the symposium. And as I mentioned, I had invited Linda and Sabrina to speak, but they said that they actually prefer to do it as a panel, which I thought was exciting because, well, it's often a lot more fun to listen to panels anyways. And so I'm just going to introduce them as the panel leads, and then I'll briefly introduce the panel members, and then I'll get out of the way. So I'm going to introduce Sabrina Sirocco. She's the director of the Graduate Writing Center at UC Berkeley. And at Berkeley, she teaches courses for graduate students on academic writing and mentoring. With Linda von Honey, she directs Berkeley's Surf Smart program, a graduate and undergraduate research mentoring program in which graduate students receive training in mentoring before serving as research mentors to undergraduates. And Sabrina also serves as co-director of Berkeley's Summer Institute for Preparing Future Faculty. And then her partner, Linda von Honey, is an assistant dean for graduate professional development at the University of California, Berkeley, and director of the Graduate Student Instructor Teaching and Resource Center for the Berkeley's Graduates Division. She teaches courses for graduate students on teaching and learning in higher education and on mentoring. She's co-author of Life Beyond Grades, Designing College Courses to Promote Intrinsic Engagement. And these two, I co-authored NSF-funded electronic publication called Intentional Mentoring, a research mentoring toolkit for graduate students and postdoctoral scholars, is based on the course that Sabrina and Linda teach at UC Berkeley. It's forthcoming. So we're kind of going to get a little bit of a preview of this, I'm thinking. So Sabrina and Linda, thank you for coming and leading this panel. And I want to just briefly introduce the panel members. And the panel members were selected because they're all well-established mentors, have run training programs, and they're all widely recognized in our field as strong advocates for diversity. Monita Chatterjee is a senior scientist at Boys Town National Research Hospital. She is presently the program director of the T32 grant at Boys Town. Karina Kramer is a professor at UC Irvine and associate dean of academic personnel for the School of Biological Sciences. Prior to this, she directed the UCI Interdepartmental Neuroscience program for 6 years. Paul Fuchs is the David Rubenstein Professor at Johns Hopkins and Vice Director for Research in Otolaryngology Head and Neck Surgery. He's the Program Director of the T32 funded program in the Center for Hearing and Balance. Ruth Lutovsky is the Oros Family Professor and Chair of the Department of Communicative Sciences and Disorders at the University of Wisconsin-Madison. She's a faculty member of their neuroscience training program. Tony Ritchie is a professor at Stanford University and Associate Dean of Graduate Education and Postdoctoral Affairs for the medical school. Previously, he directed the graduate program in neuroscience for 8 years. And Chris Scher is a professor of otolaryngology and physics and astronomy at USC. And together with Neil Siegel, he co-directs the T32 funded Hearing and Communication Neuroscience training program. Okay, so I want to just welcome everybody, and I'm going to turn off my camera and kind of hand it over to Sabrina and Linda. Thank you.
Well, thank you, John. First, we want to thank you very, very much for inviting us to take part in this very important conversation. As John mentioned, Sabrina and I have been working with graduate students over the past 15 years, training them and really helping them understand what good mentoring is and preparing them for mentoring. And I really enjoyed all the talks that we just heard, and they just really provided a wonderful sort of, building up to this panel. And I just was struck, as Chris said, that good mentoring doesn't just happen by accident. And what we have come to see over the past 15 years is that the best mentoring relationships are those that are very consciously planned, executed, and evaluated. And so we call this intentional mentoring, to really step back and to be very intentional in terms of how you're working with graduate students, not only about the research, but also about the developmental needs of the graduate students and also their sense of belonging within the group of trainees that you're working with. So we're very pleased today to have panelists, as John said, who are going to speak about how they have crafted programs that are very intentional in nature. And here is how we're going to proceed. First, each of the 6 panelists will give a short presentation on the steps that they have put in place to mentor trainees. And then after that, we have a series of questions then that the panelists will also address. And hopefully at the end, we'll have some time for your own questions. So the first question that we pose to the panel, and all six will address this, is what type of intentional steps have you taken to develop a successful mentoring program for your trainees? What does this program look like, and what kind of framework have you developed? So I think our first speaker will be Christopher Schera.
Okay, yeah, well, so first I'd like to thank John and Linda and Sabrina for inviting me to participate in this important discussion. So as John said, I'm co-director with Neil Siegel of the Hearing and Communication Neuroscience program, or HCN program at USC. And HCN is an interdisciplinary training program that brings together faculty from the Colleges of Arts and Sciences, from the School of Engineering, and the Keck School of Medicine. And faculty research in the program, it spans everything from cell biology and genetics to the technology of assistive devices, to speech, linguistics, and psychology. So it's a very diverse program. And we provide up to 2 years of support for roughly half a dozen graduate students and postdocs. And Neil Siegel and Sarah Botcher created the HCN program back in 2008 as a joint project between USC and the then flourishing House Ear Institute. And HCN has been funded by a T32 grant supplemented by USC ever since. And I became co-director only about a year and a half ago when Sarah Botcher decided to step down. And so I'm therefore sort of rather late to the HCN party, so to speak. And so anything I say about the intention behind the design of the program that Neil and Siegel, or that Neil and Sarah created, is something that I've learned only secondhand or inferred by sort of reverse engineering. And all of it, of course, is filtered through my own biases. And I say this, of course, not to deflect blame for anything that might be wrong with the program, but to give credit where it is due. So, the most important and intense mentoring relationship that trainees have is that between the trainee themselves and the research supervisor. And aside from reinforcing general expectations and monitoring trainee progress to make sure that nothing sort of goes off the rails, the program has no desire or ability to micromanage those interactions. Instead, what the program tries to do is to supplement and to enhance that sort of singular mentoring relationship. And we do this by trying to open it up, by creating and nurturing another mentoring space consisting of a community of research, teaching, and mentoring that brings everyone together. So the faculty teach a semester-long core course, which is required of all trainees, that provides both an overview of the field and more in-depth treatment of several key areas. The program organizes annual full or half-day research and clinical symposia featuring invited outside speakers. We sponsor a weekly research seminar series at which trainees and faculty present their work. And each trainee also has the opportunity to invite and host an outside speaker of their choice. The program also holds workshops devoted to writing grant applications and to giving effective presentations. And finally, we host an annual retreat on the beautiful Catalina Island, largely devoted to presentations by trainees, plus an invited speaker or so. But an important component of that retreat is a candid discussion with trainees and with faculty about how things are going, about what seems valuable and worth continuing, and about what or how things might be improved. And so the overall goal and the principal organizing theme, I think, of these and the other program activities, and it's a theme really well suited to a program devoted to hearing and communication, is to give trainees regular and intensive exposure and practice in the crucial skills of listening and communicating. And so through their courses and their seminars, trainees learn other languages. They learn the language of cell biology if they don't already know that. They learn the language of neuroscience. They learn the language of linguistics. They learn the languages of the research lab and of the clinic. So the basic framework requires trainees to present their work for feedback and then to do it again and again a few months down the line, rinse and repeat, rinse and repeat. So, by requiring trainees to present their work for feedback from diverse audiences and to write and to submit their own grant applications, The program teaches them to express their ideas clearly and emphasizes, the importance of mastering, both the details of their particular research area, of course, but also of communicating the big picture. So in our grantsmanship workshop, for example, trainees serve as their own study section. They read and critique each other's proposals. In effect, they kind of become mentors to other members of the community, acquiring skills, that we hope will prove invaluable, no matter where their future career may take them. So that's kind of the basic rationale for and the structure of the program. But let me just finish up by saying that, maintaining this sense of community during the pandemic has been a major challenge for HCN, as it has been, for ARO, for example, and really for every group that thrives best by bringing people together in some shared undertaking. So like ARO, we've tried to adapt in ways that we can. For example, Zoom allows us to schedule far more international speakers than we or the climate, for that matter, could otherwise afford. And some of these adaptations may be permanent, but in any case, we look forward to getting together again as a whole community soon. So thank you.
Thank you, Chris. Our next speaker is Tony Ricci.
Hi, everybody. Thanks for coming. Thanks, John, for putting this together. I guess I'd also like to just give a shout out to Lloyd and thank him for mentioning the DEI initiatives that are ongoing on building at Stanford. I thought I would take a little a slightly different tack than kind of listing how we do things and maybe try to bring it down more to kind of the foundational things that we need, or in my experience, have been. So first, a little bit of background on me, I guess. My training is largely as a scientist. When I started as a faculty member, I think I was a pretty good scientist, but I was not trained as a teacher or a mentor or at any real level. It was really more a lived experience type of thing. My first efforts at mentoring were really a major example of how not to do things. It was largely, well, this is what I wanted when I was a student, so let me give that to people. And I realized that, people are not all the same and people are different, they need different things. And so that at least taught me that I needed to spend more time listening to what the needs of the people are. The second thing I guess I want to say is my background and my family background is not really very educationally oriented. I guess I was first gen before I guess it was a thing. So most of my experience through education, I would not put myself as a role model for anybody on how to use universities. And in many ways, I still see myself much as an outsider to the whole thing. And also, I just want to point out that, so I would like to just talk about how I run my lab, the experience I had as a graduate program director, and also there were three initiatives that I was kind of faculty lead and founder on, or part of the team founding these programs. And one of them is called Advance, which is an onboarding. All of them have a DEI focus. One of them was Advance, which is an onboarding program for graduate students coming into Stanford across biosciences. Another is called Propel, which is a postdoctoral fellowship program to help the transition of postdocs into academic careers. And the third one is what Lloyd mentioned, which is the REACH initiative, which is a post-baccalaureate program meant to increase the pipeline and bring scholars in to give them a research opportunity that they haven't had, to make them more competitive moving forward into their STEM field of choice. I think there's a lot of commonality because we really build, the way I focus my lab is research and academic, professional development, and community building. And I think we've extended that into how we run the graduate program. and each of the other DEI programs really come from the same foundation. And for those to work, I think the underlying thing is to build a strong relationship with the individuals in that program and with the leadership within those programs. And so I think it's built on trust, and it's built on communication, kind of honest and open and transparent communication, and acknowledging that none of us know everything, and it actually takes all of us to make this work as a team. And in each of those, in each of these programs, that's really been the foundation. The difference between running my lab is I get to pick the people who are in my lab, and I get to pick the people that I'm collaborating with. And so, it's very intentional in doing that to build people that are interested in teamwork and interested in communication. When you get to programs, it's very different because, faculty come in very different flavors. Some of them see students as hands and skills and not necessarily as people. They see their role as simply to ensure that publications are coming out, and that's the level of input that they need. And so how do you mentor that, or how do you build an infrastructure to support students that are going into, in many cases, hostile environments? And so I think that, again, comes down to the foundation of good communication and trust and building an infrastructure that supports the students at a whole level. I guess I should stop. I'll stop there. If that works.
Okay, thank you, Tony. Our next speaker is Karina Kramer.
So I'd like to thank John as well for putting together this innovative presidential symposium. So I have also been, I have run a graduate program, and I share a lot of the aspects that have just been mentioned, and also the relationship with running a graduate program to leading graduate students in my own lab. And I recently, I guess a year ago, I've taken over as Associate Dean of Academic Personnel. And in this role, I'm also in charge of junior faculty mentoring, faculty development, and promotions and equity and promotions. So a lot of the principles that I developed and discovered running the graduate program have really carried over and expanded in focusing on junior faculty. And so I'm just going to highlight some of the things that have really come out of this. So I worked together with our equity advisor, and we actually developed a formal mentoring policy for the junior faculty. And before we adopted it, we ran it by the administrative cabinet, the chairs, and ultimately all of the faculty had a say in what went into this policy. And it involves having a mentoring team for each faculty member, including an outside member who's not part of the department. And this is really important because there's an inherent conflict in junior faculty mentoring when your mentor is someone who's voting on your promotion and advancement. So we have, this is sort of equivalent to an outside committee member on your thesis committee or something like that. Part of this is really deciding on what are the things that need mentoring. So when you meet with graduate students, you think about what do you need mentoring in? This involves coming up with really a clear understanding of expectations. What is expected of the mentor? What is expected of the mentee? For graduate students and postdocs, we have individual development program plans, which are reviewed by the mentor and the mentoring team and the trainee. And these should be reviewed. They're required to be reviewed every year in our department, but oftentimes it's more. And one of the things that goes along with this, especially for graduate students and postdocs, is this concept of professional development. So UC Irvine was lucky enough to have received an NIH BEST grant for 5 years to to basically develop programs for professional training. And this really focused on professional training outside academia. This has been sustained by our administration. So we now have a permanent program in place. It's called Graduate Professional Success in STEM, or GPS STEM. And because it's now part of the university, it's not only non-academic careers, but it's also academic careers. So we have programs for grant writing, internships with industry, et cetera, et cetera. And one of the things that I've noticed about this is that there's been a cultural shift in the way that faculty view professional training. Certainly when I was a graduate student, you were a successful trainee if you went on to get a tenure track position at a major university, and otherwise you were pretty much not. Now success looks very different, and there's a widespread acceptance of our responsibility to train our postdocs and graduate students, regardless of what they want to do. And here again, we have to recognize the need for potentially pointing our trainees in other directions. We can't train them and mentor them in, say, going into industry or publishing or something that we've never done. And so one of our responsibilities there is to help point them in the right direction to find other mentors. Finally, I think one of the things we have to really consider is that trainees come from different cultural backgrounds. They haven't had the kind of experience that we've had. And one of the things that's been a really big focus at UC Irvine is culturally aware mentoring. One of the things I've been really pleased to discover is that we've put on all these trainings for faculty in culturally aware mentoring. We did not require it, but there was an overwhelming response of faculty who volunteered to do it. So the thing is here that our trainees need culturally aware mentoring, and the majority of our faculty are very interested in learning how to mentor and learning how to mentor in a culturally effective fashion. With regards to the first talk, the way these trainings worked was with, they were on Zoom, of course, but we had tiny little bit of lecture, and then we did activities, active learning activities, practicing in breakout rooms. And then one of the programs also trained us to become trainers of mentors. So this has been a really very effective program that I highly recommend. We also learned a lot about advocacy and sponsorship. And those are also roles that I've had a lot of in as both graduate program director and in my role as associate dean. And that is, part of it is mentoring faculty, but part of it is also standing up for them, nominating them for awards, introducing them to people at ARO every time you can go, when we can go live, helping them network, helping them build collaborations, et cetera. And so I think I'll stop there, but those are sort of the main tenets of both of the programs that I've been involved in.
Thank you, Karina. Our next speaker is Paul Fuchs.
Am I on? Okay. So thank you, John, for asking me to participate. And I want to also thank all of the presenters as well, because I've learned a lot, and I'm very encouraged by what I see as commonalities both in philosophy and strategy. So intentional steps that I've been engaged in fall into two broad categories, so I'll deal with them that way. The first is programmatic. So I direct the Center for Hearing and Balance, which has existed for over 40 years. It began as a Center for Hearing Sciences under the direction of Murray Sachs and then Eric Young. And it began as a collaboration principally between two departments, otolaryngology, head and neck surgery, and the biomedical engineering department. But in the past 10 years or so, the Department of Neuroscience has become an important part of that teamwork. And even more recently, psychological and brain sciences on the undergrad campus is also now contributing not only faculty, but students. So currently there are about 27 member laboratories that participate in the training program. And among them, there are something on the order of 40 postdocs and 40 pre-docs. We teach a core curriculum each year. It's a course that takes place in the fall called Structure and Function of Auditory and Vestibular Systems. It's a biomedical engineering course they get credit for. So all trainees are required to take this, in particular those that are on the training grant that I mentioned. And in addition to which postdocs, of course, are encouraged, they can take it as auditors. We have a weekly seminar series, like many programs. This includes internal and external speakers. The external speakers that are expected to be invited in part by the trainees. And of course, for all the external speakers, there's opportunities for the trainees to meet with them individually. Back in the day when we were all live, that meant a meal. Nowadays, it's something different. In addition to the sort of research seminars that series provides on, as I said, a weekly basis, we also cover a number of different required topics, career development topics like responsible conduct of research, reproducibility and reliability of data, career path options. So for instance, recently, in the past year, we've invited former trainees of the program who are doing non-academic careers very successfully in venture capital for biotech, for example, in high-level administrative positions at other universities, in science communication, et cetera. So we're trying to demonstrate that kind of career diversity that we think is a very good option for our trainees in the long run by actually showing them examples of how it can be successful. And finally, we have also a series of ad hoc kind of training workshops that are very technically oriented. So for example, Amanda Lauer will teach about how to measure hearing, looking at ABRs and distortion products, et cetera. I do something myself on fundamentals of electrophysiology, not every year, but sort of every other year or so. Our trainees have opportunities to learn to teach themselves, which I think is very important. So they all can participate in the teaching assistantships within their home departments that grant their degrees. The Center for Hearing and Balance program is not degree granting. They can also, postdocs can teach if they wish, but most don't. But also our trainees have the opportunity to serve as teaching assistants in some of the national courses like Biology of the Inner Ear at Woods Hole and the Mouse Phenotyping course at Jackson Hole. Again, these are outstanding opportunities to develop their own teaching credentials and abilities. They're all encouraged to apply for individual fellowships. And last but not least, the institution mandates that every trainee go through an annual individual development plan process, which is a form that has a number of criteria that have to be covered, and that has to be signed off by both the trainee and the mentor, and then maintained in a record keeping by the department, the home department. So that's the programmatic stuff. Personally, how do I regard mentoring? Well, let me just go through a few things. The first thing I always want to do is to assess the degree to which the candidate's interests really intersect with those of what I can provide. So in particular, in the research laboratory, I'm hoping this is not someone who's just setting out a shotgun blast to 5,000 different labs and hoping to land something. If I don't see something that indicates a real interest in the kind of topics that I'm interested in, that our lab has a history of working on, then I'm much less enthusiastic. I also want to know by speaking to the applicant whether their skill set can contribute to our program, and can we provide something to them that will be complementary to the things that they're already good at. I also want to know about the long-term aims of the candidate, and this doesn't mean that I say, I hope you're going to become a professor. As I mentioned, we have lots of different outcomes for the trainees in our program. And even from my own lab, I can talk about a variety of different programmatic outcomes for our trainees. In fact, I think it should be a principle that all of us consider very strongly, which is that we are funded by public funds to conduct research programs and to do the training and do these other things that we do. And that benefit to the public that supports us should be much wider than just generating clones of ourselves as professors. I think we should have an impact on many aspects of biotech, the economics, communication, you name it. There's lots of ways that the training that we provide can benefit society more broadly. And so last but not least, I'll say something about over time with the trainees, I observe their strengths and weaknesses. I try to encourage them to utilize their strengths. So I've often had the conversation with someone to say, what do you like to do? You know, what feels good when you're doing it? And if that's something you can identify, that's probably something you ought to try to use in your future, because I know from my own training and education, once I hit on something that I really got satisfaction out of doing it, that was such a strong motivator that it was really helpful. And then if they have weaknesses, well, then I try to provide some gentle but firm criticism and help them find ways to ameliorate those weaknesses or improve on them. So I'll stop there.
Thank you, Paul. Our next speaker is Ruth Latowski.
Can you hear me okay? Great. Well, thank you so much, John, for the invitation and for organizing such a fantastic session, such an important topic. I'm so excited to see both mentoring and DEI work reach such a high level of attention and interest at ARO. These are both areas that have been really important for me. And I remember maybe 15 years ago, I started the mentoring program at ARO and other conferences, specifically to provide a safe space for trainees to meet other people and to connect with mentors outside of their sphere and their circles. And the goal was to build relationships and expand opportunities. And it's been fantastic to see Sparrow take this over and make it their own. And it's grown really beautifully. And in the DEI space, I should say that in my role as professor at the University of Wisconsin, I've gotten involved in a lot of faculty governance early on in my career, but especially as I moved into, more senior positions, and I felt more safe getting involved in spaces like DEI, writing the new campus diversity plan, and drilling down to spaces that, where you get a chance to truly engage with and actually demand from high-level administration that they implement change. And there's a lot of risk that sort of happens there. And so, part of my approach to being mentored early on and then mentoring is to talk about what it means to stepping into risky spaces and what that means as you move through your career. So in my own lab, over the years, we've had as many as a couple of dozen people in the lab, and also now for a number of years in my role as department chair. A lot of what I talk about and try to achieve in mentoring is scaffolding mentoring at multiple levels and focusing on community building. I think it's really important to create safe spaces for discussion and for support. In my lab, I've worked hard whenever possible to recruit diverse participants and really think of lab participation and joining the lab as an intentional process where, everyone in the lab interviews folks who apply to come to the lab, and I think about their background and experiences and the way that people treat one another. And it's been very important to me also to see us people leave the lab and we've remained close and sort of see the ripple effects of the mentoring and the relationships that continue. And, going back to the topic of creating safe spaces, I think it's really important to celebrate people's personal growth, to understand what their needs are, and to have really in the lab, when we have regular meetings and in departmental meetings and in seminars that we have, to really have a space where you can have open discourse about science that's authentic and respectful, and sort of finding that balance between communication, challenging one another, and having the students feel that they can step into the space and grow and learn from people, not only in their sphere, but outside their sphere. As far as mentoring, individually, I think that it's very important to understand for each mentee how they can be their best selves, not someone else's best self. And what are they going to do to find what resonates with them? What brings them to a specific program in a specific lab? And what are they most curious about? And sometimes they know that, out the gate, and sometimes it takes a while to develop those areas. And so encouraging mentees to continue to explore what resonates with them, while at the same time trying not to spin their wheels for too long, and helping them to develop skill sets and feel that they can be productive. But really helping, I think we need to, my goal is to help mentees figure out what their questions are and how they want to address them, and what the tools and techniques are that they need to achieve their goals. And so, in my own space, and then as I mentor junior faculty, we talk about starting out with more directed mentoring and then pulling back gradually to give folks more independence. But I think all of that has to sit in the midst of a really supportive environment that encourages people to seek community and find cohorts that they can talk to, that they can learn from. And within my own lab, very few people work in their own silos. So we've created these focus groups where people can collaborate and work together and build on each other's knowledge and support. So there's a lot of sort of intersection and communication and support that happens, and a lot of sort of training development. So by the time somebody leaves the lab, hopefully they have a lot of skill set that they can take with them. I want to also mention that we've worked very hard in the lab to write our own diversity, equity, and inclusion statement, and to weave that into the part of most of what we do in the lab. So at lab meetings, we create spaces to sift and winnow and write statements together, and to go back and explore our communication styles and understand what are the best ways that people can bring themselves to that space, and also to revisit and hold each other accountable in those spaces. And the last thing I want to say is that I've taken mentoring junior faculty very seriously, because they're the future of our field. And I think that, understanding what brings people to a department, to a division, to the field, and helping them be the best that they can be is extremely important as well. Okay, I'll stop there.
Thank you, Ruth. And finally, our next speaker is Monita Chatterjee.
Hi, thank you for including me in this fantastic discussion. I thought I'd provide a mix of my approaches, both as the postdoctoral training program director at Boys Town, which the program is now in its 42nd year, I think, and I haven't been director all that time. I'm younger than that, but I've only recently taken it over. And also as a lab director. So in a programmatic sense, I'll just mention a couple of things that have not been mentioned as yet, I think. One is that just based on my own experiences as a woman of color, coming through an engineering program, a PhD program, postdoc training, and then as faculty, I realized the great need for cohort and networking. And I've just helped with some friends initiate a BIPOC network in people working in communication sciences and disorders. If anybody here is interested, it's a fledgling network. The idea is to provide a cohort, resources, mentoring in the broad field to anybody at any career stage. And we've only been around for a couple months, and we already have 60 people in our email list. So I think the need is very much there. I hope we can address it appropriately. So I'm very excited about that. And that's in the broad programmatic sense. And then also within Boys Town, we really like the individualized development plan. So when a trainee comes in, they work with their mentor for a month or two before they develop that. So that allows them to, as I'm sure all of you are aware, have these short-term and long-term goals, which we have a research training committee that's outside of the lab. A few people from different career stages get their eyes on that individualized development plan and provide some input, guidance. Sometimes, in the past, I've noticed postdocs or students would go into a lab and disappear, and then you don't know what happened, So it's really nice institutionally for us to have this kind of, not really micromanaging in any sense, it's just feedback that the mentor and mentee are welcome to take or not, but we found this very helpful. We visit that development plan for each trainee a couple times a year at least. And in my own lab, I like to, use that as a real benchmark process, to see how we're doing. So the other thing programmatically that we like to do at Boys Town is, because nobody's really trained in how to be a mentor, if we have a trainee coming in wanting to work with a mentor who doesn't have that much experience mentoring, we offer the option of a co-mentor who has to get along well with the mentor and has enough understanding of the field and experience and can help, help in the whole process as needed. This co-mentoring thing has worked really well in our experience. I've served as co-mentor for a couple of my early career colleagues, and I think it's been a really nice option for them to have sometimes. So in my own lab, I think it's been really important for me to understand that not all trainees are the same, and that they're not all exactly like me. They don't think like me. They may have different goals than I did, and so understanding that they might also have different stressors. Some may be financial, some may be because they're very insecure, or having, what we call imposter syndrome, and worried about letting me down. So that awareness, bringing that awareness to mentoring has really helped me. And it's something I've learned from my trainees over the years. One of the things I think that really helps is sharing all my missteps, with the lab in an open way, and also telling them about times when I've messed up and or when I've been challenged in some serious way. And so this creates, I think, an openness that provides, hopefully, my trainees to feel comfortable taking risks, not to be afraid to make mistakes, because it's something that everybody does. And those are often the learning points. So those are things that I emphasize a lot, that until you make a mistake, you haven't really learned something new. You haven't had that opportunity, and that I think also just hearing about how I came through situations, it gives us an opportunity to look at, maybe the benefits of being tenacious and resilient, but also, well, maybe Monita, you could have handled this differently, And so it's a really good discussion space, I think, to bring my missteps into discussion. And I do think that, common ground is so important. So in a lab, you can have conflicts between people, you can have all kinds of problems, but the more there's interactions about not just the science, but about what did you read, recently, and what did you think of this show on Netflix? And, the more we have common ground, because my lab tends to be pretty diverse and people come from different backgrounds, and there can be some conflict sometimes, and I find that that's really beneficial. I learned from my own mentor, Bob Shannon, this value of, the first thing we talk about is something not scientific. We talk about music, or we talk about something else. And that common ground is something that we can then build on, and I think that's really an important thing in my lab, at least. finally, I'll just say that I think it's really, important to keep in sight that the goal for me in training my trainees is that when they're out of my lab, they should be able to basically set up their own lab. They should be independent thinkers and doers. And so I always try to keep that, in the forefront of my goals with these trainees. And so, whereas in the beginning, maybe I help them learn some skill sets, very quickly, I will be encouraging and pushing as much as I can for them to develop their own project where they're going to be first author on those studies, and I think I will stop there.
Okay, thank you. What's really interesting, if you think about how we prepare graduate students and postdocs for their future careers, historically, research universities have done a pretty good job at teaching graduate students how to do research. And then I think in the 1990s, we also began, most research universities, thinking about how do we prepare graduate students, or how do we teach them how to teach? And what's happening now, as you can see, even on this panel here, and from some of the things that we've been doing also at Berkeley, is we're beginning to see that we need to consciously teach people how to mentor also as well. And Karina mentioned the program that they've started at Irvine, I believe, for junior faculty, and there are others. But the question becomes also, how did you learn how to mentor? So this is a question we ask of a few of the panelists, and we'd like to hear how you learned how to mentor graduate students and postdocs. So I think, Paul, you were going to kick this off.
Yes, thank you, Linda. I'll do that. So I learned to mentor by example. Beginning in high school, I learned a very valuable lesson, which was that those faculty members, my teachers that paid attention to me, provided me with the most benefit. So as I continued through my educational career, I looked for people that I sensed that capacity in. I consciously looked for mentors that I thought had the kind of sensitivity and capacity to listen to me, and thereby do a better job of guiding me in a direction which was appropriate for my own abilities. So this has taken many forms. And of course, the kinds of mechanisms and the sorts of tasks that requires changes over time. In my current position, I'm particularly interested and engaged in helping trainees to achieve their next career position. And it reminds me of something that happened to me when I was completing my second postdoc, which took place in England. My postdoctoral supervisor from the first postdoc, a wonderful guy named John Nichols, helped me to set up a speaking tour in the United States. So I went around to 12 or 13 different places. These were not explicitly job talks. It was just getting my face out there. And then ultimately within the year, I began receiving, or had an opportunity to apply for jobs in 3 of those places. And so eventually wound up at the University of Colorado. So I hope that that was a good message and a good lesson for me that, especially now in the pandemic, where we don't have the opportunity to visit and go face-to-face to the ARO meeting and do all the things that were so useful in terms of finding our next contacts. Now I think it's incumbent upon us to all make an effort to find those connections for our trainees, help them to establish a visible presence in the field. I'll stop there.
Monita, I think you wanted to weigh in on this as well. How did you learn how to mentor? I think you're muted still, Monita.
Yeah, I was having some trouble getting to that for some reason. Sorry about that. So I think I was just talking about this, that I learned from my trainees and I learned from my mentors, as I'm sure all of us did. One of the things I did early on was to make notes of things I didn't like that my mentors did, that my friends, cohorts, mentors did, and literally have a list in the back of my head of things not to do. And one of them was—
Could you share that with us, please?
I'll share 2 of them. One of them was keeping the communication channel open all the time is really important. And I really felt that when mentors became very hands-off and delegated mentoring work, it it never went very well. And from basically what I heard from my friends, and I am much more hands-on. I try to keep the lab manageable so that I can do that. The other thing that I noticed was when people didn't take much time to figure out what the trainee really wanted and didn't listen well enough. And I think Paul just talked about the value of that, right? Being listened to. One of the things that my mentors did, and so, I've had two primary mentors in research, both were white men, and I really appreciated that they took time to understand they knew already and took time to understand my background, the history of the place that I came from, my cultural leanings and so on. And I thought that was really helpful, that they really reached out to understand who I was as a person, and that really benefited my training. So I try to do that. I have to say that cohort made all the difference when I was a student. And I didn't have the opportunity of having a cohort of people of color or many women, but in science, but I did have a cohort always. And that cohort has helped me tremendously. From my trainees, I've learned a couple things that are most important. One was that they pay attention to everything I say. So what I say, I can't be like joking around too much, because they will take it to heart sometimes, because what you say as a mentor is really impactful for them. So that was an important lesson that my trainees taught me. What I don't say is very important too. So if I'm talking about how great somebody's work is, and I neglect to talk about somebody else, person B, who's sitting there patiently, as well, that has an impact, So being, as inclusive as I can, being as thoughtful as I can, these are things that maybe were not so natural for me. And I learned, over time. And as I said, just realizing that not everybody thinks the same way that I do, and paying attention to that. So let's stop there.
Okay. So stepping back, what would you say are the fundamental qualities of a good mentor? Many of you have touched upon this, but I thought maybe Ruth and Christopher could say a few words about that from your perspective.
Sure. Chris, should I go ahead and say a couple things? Or maybe you can mentor me on what to say. I think that in science, and most of us, I think, work at universities, we are, at least my training was, to kind of build up, a lab and to try to be productive and to try to get excited about the things that I was really wanting to move forward, in my own career. And then bringing mentees into that relationship and committing to those mentees, you sort of pivot to a different space. And I think it's really important to take those relationships seriously and to learn about what each individual wants, what brought them here, and how they want to get there. And I'll drill down to one specific example, which is that in our field, which is hearing science, and it's connected to a lot of opportunities that are both in academia and in industry. Many of the mentees, who come to work with me at some point consider whether they want to go work in industry or they want to stay in academia. And those are very important conversations, and helping them sort through how to get to that point. Does it mean that you take a break from the lab to go do an internship, outside of academia? Does it mean that we build collaborative relationships with people in industry, and that gives you a foot in the door? But really not, I remember that my PhD mentor, sort of she was a wonderful mentor, but she basically told me that if I left academia, she would be disappointed. And I was determined not to put that onus, on my students and on my postdocs, because it's their life. And everybody has to make the decision that will be really the best for them. I also think that mentoring is a long-term process and a long-term relationships, and to really help scaffold people both in the hard times and in the good times. And people are, going to go through ups and downs. We saw this, a lot during the pandemic, and to continue to support folks, even when they feel like they've lost the thread, or they're not feeling, encouraged by what they're trying to do next, or, they've not succeeded at getting a grant or at getting a publication, just to continue to be positive, supportive, loving. I mean, I really feel like, there's a sort of even a bit of a family relationship. We build these relationships to last a long time. But the main point is also that it's not about me. One of the fundamental qualities of being a good mentor is that it's not about me. It's about what is the best for the trainee, and helping them be the best they can be.
Chris, would you like to add something?
Yeah, sure. I guess I might rephrase the question slightly, maybe along the lines of, what should a trainee look for when they're choosing a mentor? Of course, it basically goes without saying that you want to find someone who's really good at what they do so that you can learn from them. But it's also very important that the person you choose actually be interested in mentoring. Perhaps I can share an anecdote. When I was a physics graduate student at Caltech, I had to put together a thesis committee like everyone who gets a PhD does. And my research supervisor, George Zweig, had also gotten his PhD from Caltech and had been a student in his day of Richard Feynman's, who was still on the faculty. And so George suggested that I ask Feynman to serve on, and indeed to chair my committee. Now I've actually found this to be a rather intimidating suggestion. So I asked George to elaborate on the pros and the cons. And after a long pause, George shook his head and he said, I take it back. It's not a good idea after all. Feynman has no interest in students. So if you were to make an appointment and go to his office and patiently show him all about the fascinating problems that you're working on, and ask him to serve on or to share your committee, one of two things would happen. Most likely he would dismiss the problem you're working on as uninteresting and tell you that you shouldn't be wasting anyone's time on it, least of all his. Less likely, but actually even more devastating, is the scenario where he actually finds the problem worthwhile. Because in that case, he would go home that evening and return the next morning having solved the entire thing overnight from scratch. So neither of these two hypothesized responses is especially good for trainees. So needless to say, I never asked Richard Feynman to serve on my committee, and I never told him what I was doing either. Good mentors, they have to be interested, not just in science, or as Paul was saying, in increasing, the output of the laboratory, but they actually have to be interested in mentoring. And this takes time and patience. It requires allowing trainees to discover things on their own, to make their own mistakes, to learn from them, perhaps to flounder about for a while, but in the end, as a result, to achieve their own successes. And none of this, requires compromising on standards. High standards and high expectations for your trainees are essential, but it does require flexibility and an ability to listen. As people have said, not all students are identical, not all have the same strengths and weaknesses, nor do they have the same needs, or do they make their needs known in the same way. So there's no rigid, one size fits all approach to mentoring. And I think recognizing this and acting on it, that is perhaps, the most crucial thing of being a good mentor. So I'll stop there.
So one of the most crucial elements we think of really developing successful programs is to take the time to assess and evaluate how things are going. And this is also something that often doesn't get addressed in even the research on mentoring. So I'm wondering if, Karina, if you would say a few words just about how you go about evaluating the impact of your mentoring?
So we did just, we had a question about this, and I'm glad that this came up. We actually run a survey on our junior faculty mentoring and for our graduate program every year. And we've already, since we've just started it last year, we've already made changes reflecting what are the things that the mentees need that they're not getting, or what are the things that we're requiring that aren't really serving them or taking too much time. So this is, it's really important when you create a mentoring program to remember to be flexible. It's not, it's not like you make it and you can't change it. If you make mistakes, you'll change it, you'll improve it over time. And with the junior faculty, obviously, you're successful if they get tenure. But one thing I look for more is they get tenure and then they volunteer to be on a mentoring committee because they realize the value of that's a sign of success. With graduate students and postdocs, especially with graduate students, there's this there's a problem because a lot of the time, both graduate students, postdocs, and especially junior faculty will feel like they want a set of clear expectations for what it's going to take for them to get their PhD or to get tenure. But because we're working in a field that is completely original and creative, the answer can be, okay, you have to do something really great that no one's ever done before, and you'll publish it in some amount of papers. And we can't tell them exactly what it takes. But I feel like one measure of success in these mentoring efforts is when the mentees accept and work with that uncertainty and kind of put their own creativity into designing their project and coming up with something that is creative and original and enough, and whatever that means. We know it when we see it, and then they see it, and that's a sign of success. One other thing that we do that's been working really, really well in our junior faculty mentoring is we get together with the faculty member individually. We also get together with the mentoring team, and we talk about all of the things that were outlined in the mentoring plan, how to write grants, write papers, teaching, running the lab, et cetera. We kind of talk about all of these things. But then after the meeting, we write a written summary of the key points and we send it to the trainee. And sometimes they have something to add, or they might have questions. But what that does is it helps them focus, because sometimes when someone's being mentored, they kind of hear what they want to hear, or they emphasize something a little bit differently. So this pulls everybody together on the same page, so that when you get together the next time, you can say, well, how well did we meet the objectives that we identified the last time? And again, this is why it's really, really important to have milestones, to have an IDP, to have clear expectations of what's going to be done and by when, and what are we going to do if there are problems. And so I'll stop there.
Chris, did you, excuse me, not Chris, Tony, did you want to add something?
So, I think I agree with everything Karina was saying, and we have similar types of feedback in each of our programs. I think we try to be intentional about assessing short-term and long-term successes, both for the program and for the scholars that are in the program at whatever level they're at. I think so. We are asking participants within the program, basically, are they getting what they need from the program at each level? And as I mentioned, there's kind of an academic, a professional development, and a community building side to each of the things we do. And each cohort that comes in has completely different set of needs and expectations. And so you really have to have kind of iterative feedback, otherwise you're kind of outdated pretty quick, and building I'm tend to be lazy by nature. So, building program that nobody's actually interested in doesn't really attract me. So I try to make sure that we're giving people what they're actually looking for and where the needs are, and then getting feedback on that. An example is what when we survey graduate students pretty yearly, we find that the students that do the onboarding program, the summer program called Advance, consistently say that they feel that they take advantage of the resources available at Stanford at a higher level. They feel more like they're part of a community than the students, comparable students in a given cohort feel. And so to me, I would define success in that way. It's not, oh, are they publishing at a higher rate, or did they qualify and whatnot. Although those are also metrics that are used, those tend to kind of be a wash. I mean, the students at Stanford are really pretty successful in meeting benchmarks around their scientific progress. And so it's hard to find added advantage there. But looking at the bigger picture, are students, happy in their environment? Are they not as stressed out as everyone else in the environment? Are they getting the support around work-life balance and, time commitments? And are they getting the training more holistically around things that will take them forward? We can assess, and there's a huge range of responses there. So there's plenty of room for improvement. But we also survey, after students leave. So for me, out of my lab is very similar in my mind to, say, out of the graduate program. Are the people coming through the lab using it as a stepping stone to get to the position they want to? I don't feel like it's my job to judge where they want to go, just to ensure that they get there, that they have that opportunity. In my mind, if they've made it to my lab, or if they've made it into this graduate program, they've already been highly successful. And so my job is mostly not to interfere with that trajectory and ensure that they continue on in that and be successful. And so we try to follow up and see if they've been successful, and also get feedback on, well, now that you're out in the real world, what should we have done to better prepare you for this position? What could we have done? How can we build that in, for future generations?
That sounds wonderful. Okay, I'm going to turn this over now to Sabrina.
Okay, we're getting close to time. So unfortunately, we had wanted to address a bit more the role of the mentee, which we feel is equally important as a mentor, because most of the discussion tends to focus on what the mentor does, which is very important, but what does a mentee do? And we had hoped, but we didn't, and because we had such a rich discussion. But in terms of what are the expectations you have of the mentee? Are those clear expectations? And how do you work with mentees who perhaps aren't ready for this, aren't up to speed, or maybe don't have all the skills you would like them to have yet? So how do you kind of prepare and have mentees ready to go? And how do you ensure that they become successful mentors in the future, which I think all of these things have been addressed through the presentations this morning and with the panelists. But I kind of going back to the title of this session, intentional mentoring, that intentionality is both on the part of the mentor and the mentee. And those are the things I think to be thought of when you are crafting whatever type of mentoring program or relationship it is what exactly are the goals, outcomes you expect, be it succeeding through your graduate program, be it in terms of training how to be a research mentor. And I'll just say that the course that Linda and I teach at Berkeley for graduate students, effective mentoring in higher education, the two goals of that program are for graduate students on how to be effective mentors and how to be effective mentees. And that as mentors, that they're going to be looking at their mentee, how that relationship's going to work, and vice versa. What are their mentors expecting from them? And I'm so sorry, that's all we could say about this because it's a huge topic. And we only have about, half a minute left. And I think Linda and I would just want to thank John for inviting us to participate in this panel today, this symposium, and the wonderful presenters and just wonderful panelists. We've really enjoyed and have found this wonderful process. And hopefully it's been as productive for all of you.
Oh, Sabrina and Linda, thank you both. You just led a wonderful panel, and to all the panel members, thank you as well. I learned a lot, and I'm sure our membership did too. I did want to ask Allie a question, or Dawn, whoever's listening. So I realized that there's a few things I may have missed during the talks today, even though I've been paying attention and taking notes. These are recorded, so I could go back and like skip to the part I want to watch and then take some more notes.
Great question. Yes, everything is recorded and will be up online within 24 to 48 hours of the session occurring. We're just going to cut them and clean them up a little bit, and they will be on the platform in the same place that you clicked to access the session today. You'll see a little recording icon.
I see. Oh, that's great. Now, if I wanted our program coordinator staff to watch some of these, would I have to use my login for them to see it, or can they just access it for free on the internet?
Currently, the videos are only for registered attendees.
Okay. All right. Well, I'll cheat the system a little then. And it'll be up for a few weeks, I'm assuming, after the meeting, right?
Correct, for 14 days after the meeting.
Okay, great. Well, thanks, everybody. And it's time for lunch for me, and then we'll kick off the afternoon session, I think, in about 30 minutes. So, thanks very much.
Thank you all so much.
Thank
And if
you,
you have
everyone.
time during the break to visit the exhibit hall or the e-poster gallery, please do so.